everyone and welcome to this video on the C++ full course by Edureka. C++ is a powerful high-performance programming language that extends C with object-oriented programming features. Known for its efficiency and control over hardware resources, C++ is widely used in system software, game development, real-time system, desktop application, and scientific computing. Its standard template library accelerates development with pre-built data structures and algorithms. C++ remains essential in modern software development due to its combination of high performance, low-level capabilities, and OOPS features, making it a versatile tool for a wide range of applications. Before we begin, let's outline today's agenda for this C++ full course. First, we will explore the history of C++, followed by guiding you through the installation process of a C++ compiler and IDE and running the first Hello World program. Next, we will discuss the key features of C++. Then we will dive into the detailed structure of a typical C++ program, explaining its main components. We will then cover data types and variables, including their declaration and initialization. After that, we will explain various operators in C++ with examples. We will discuss control flow with conditional statements and loops, teaching you how to use if, else, switch statements and implement loops like for and while. We will also cover functions including their definitions and how to pass arguments. Next, we will introduce you to classes and objects in C++, followed by an in-depth look at object-oriented programming concepts such as encapsulation, inheritance, and polymorphism. Finally, we will explore the standard template library focusing on the usage of vectors and other constraints, ensuring a comprehensive understanding of essential C++ topics. Finally, we will compare C, C++, and Java as well as Python and C++. To conclude, we will discuss some of the frequently asked C++ interview questions and answers to help you prepare for interviews. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for the C++ programming course, the link to which is in the description box below.
The C++ programming language is developed in the year 1980 by Mr. Brane Strausstrup at the well-established Bell Laboratories of American Telephone and Telegraph, popularly known as the AT&T Company, positioned in the United States of America. He developed a C++ programming language in order to integrate the object-oriented style of programming into C language without having to make any significant change to the C fundamentals.
Before we move ahead with our next module, I have a simple question for you guys. And the question is, who is the creator of C++? Options are given on the screen, and if you know the answer, please leave it in the comment section below. In our previous module, we explored the rich history of C++. Next, we will dive into the installation process of C++, where learners will learn about setting up a compiler and IDE to start coding in C++.
To run a C program, we are going to go ahead and install MinGW and VS Code. So for MinGW, just go ahead and type MinGW and hit enter. On the first side, you'll see SourceForge, and there you can just go ahead and click on it. After that, there will be a download option right below it. Click on that. Your download will start shortly in like 5 seconds. Just wait. Yeah. So make sure you are downloading in correct place. So our download is complete. I'll just go ahead and run the extension. Click on install. Keep the default, it will be helpful later. It is going to download the setup of MinGW installation. After that, click on continue. Then you have to select the packages that you want to install in this. So I'll just go ahead and mark all. After that, in the installation, you can go ahead and click on apply changes. After that, apply. It will download and start installing. After that, just close it. We'll close everything. And for the next step, we'll need VS Code. So type VS Code in your browser. Just go ahead and you can directly click on download or you go to their website for a particular version. I'll download for the window. It will start the download automatically. Download has completed. Now just run the extension. Accept the term agreement and next. After that, keep the path default only. Click on create desktop icon and check these boxes also. So you can open the code and the other program from the file explorer itself. Click on the next and then start installing. I'll just click this because I don't want to launch it right now. So after we installed 𝐸𝐺W, we have to add it to our path. So for that, go to File Explorer and go to your local disk. In that, you'll find 𝐸𝐺W folder. Click on that and then bin. Go on the top and copy the path. After that, go to your search bar, not in the Chrome, the Microsoft, and type environment variable. Find the path in system variable. After that, click on edit. It will show you all the environment variable available. Now click on the new one and paste that path. After that, click on OK and OK. Close the window. So now 𝐸𝐺W is installed and we have added path to our variable. After that, we also installed VS Code. Now we'll open VS Code and then we'll add some extension to it so it can run our C programs. Find VS Code. So let me create a new text file. Before that, go here, find the C++ extension. After that, click on install. It will start installing. Meanwhile, we'll install Code Runner. It will look something like this and we'll just install this one also. Go to file, create a new text file and we'll start it in the saving. Name it my C++ program. Use extension .cpp. So now our VS Code recognize it as C++ program. Now we're going to type the code. First include the header. So this is our program. Make sure use return to avoid any pointer mistakes. And it will give us a hello world. Now let's run and see this. Use Ctrl Alt and N or just save it before that. Let's run it again. Yeah, so we can see hello world is there as we expected and it is in 1.78 seconds. I hope now you know how to install C++ and Visual Code, and we also saw how to run a program first.
Here's another question for you guys. What is the correct file extension for a C++ source file? And the options are option A .java, option B .cpp, option C .py, or option D .txt. If you know the answer, please leave it in the comment section below. In our previous module, we covered installing C++ and running our first Hello World program. Moving forward, we will examine C++ key features and detailed structure of C++ programs, focusing on essential components and syntax.
So firstly, we have rich library. C++ language incorporates multiple built-in arithmetic and logical functions along with many built-in libraries which make development faster and convenient. Next, we have the object-oriented style of programming. C++ programming language is designed to be an object-oriented programming language. Object-oriented programming style makes development and maintenance easier, whereas in case of procedure-oriented programming languages, if the code grows, the complexity grows proportionately. Now, let's move on to the next feature, which is compiler-based. C++ programming language is a compiler-based programming language. It means without compilation, no C++ program can be executed. First, we need to compile our program using the compiler, and then we can execute our program. Followed by this, the next feature is extensible. C++ programming language is highly extensible because of its easy adaptable features. Next feature is recursion. C++ language supports function backtracking, which involves recursion. In the process of recursion, a function is called within another function for multiple number of times. Then we have pointers. C++ enables users to directly interact with memory using the pointers. We use pointers in memory, structure, functions, array, stack, and many more. Then we have structured. C++ programming language supports structured programming, which includes the use of functions. Functions reduce the code complexity and they are totally reusable. And finally, we have memory management. C++ provides the best-in-class memory management. It can both allocate and deallocate memory dynamically at any instance of time.
Now let's take up a quiz question. Which C++ feature allows derived classes to inherit properties and behaviors from a base class? And the options are option A, polymorphism, option B, inheritance, option C, encapsulation, or option D, template. If you know the answer, please leave it in the comment section below. Having understood the basics of running C++ programs, we now shift our focus to exploring identifiers, keywords, white space, data types, and variables, which are essential building blocks of every C++ program.
So what are identifiers? Identifiers in C++ language are none other than the names assigned to the variables and functions used in a C++ program. The valid identifiers in a C++ program are declared using alphabets from capital A to capital Z, or small a to small z, and even you can declare a name using the numbers starting from 0 to 9. The identifiers cannot include special symbols and white spaces, but you can include an underscore. One basic example of valid identifier is int x is equals to 10. Now let us discuss some rules to declare identifiers in C++ program. So the rules are simple. First character should always be an alphabet or an underscore. Followed by that, succeeding characters can either be digits or letters. The third rule is that special characters are not allowed except the underscore. And fourth and the final rule is identifiers should not be keywords. To understand these rules, let us check out some valid identifier names as well as some invalid identifier names. Firstly, we have int a, which is a valid identifier because it is starting from an alphabet. Followed by that, we have another one which is int underscore ab, which is also valid because it is starting from underscore. Then we have int a30, which is valid because the first letter is starting with an alphabet. Followed by that, we have numbers. Then let's check out the invalid identifier names. We have int2, which is starting with a number, so it is considered to be an invalid identifier. Then we have int a, white space b. It is starting with an alphabet, but it includes a white space, which is not allowed. Then we have int long. So the fourth rule speaks about this type of identifiers. Identifiers should not be keywords. We have long, which is a keyword that is a data type. So you cannot name your identifier with a data type or a keyword. So these are the few rules for declaring identifiers. And with this, let us move to the next chapter, that is the keywords. So what are keywords? Similar to identifiers, we do have some special and reserved words in C++ program which have their own special meaning. Such words are called as keywords. Some of the keywords used in C programming language are as follows, and after that we shall deal with some new keywords which are introduced from C++ language. So these are the keywords which are used in C programming language as well as C++ programming language. So they include default, break, case, char, long, and many more like delete, struct, switch. Now let us move to the keywords which were introduced from the C++ programming language. So these are the new keywords which are introduced from C++ programming language. They are ASM, delete, virtual, template, inline, protected, throw, catch, and many more. So with these, let us move on to the next chapter. The next chapter is white space. White space can be defined as a term used in C++ programming language to define blank spaces, tab spaces, new line characters, and comments. White space separates one statement from another and enables the compiler to identify where one element in a statement, such as an int, ends and the beginning of the next line. Let us consider a basic syntax to understand white space. Here we have char Edureka happy learning. Char is a data type and Edureka happy learning is the name of the variable. So between the both we have a space which is the white space. Now we have understood what exactly white space is, so with this let's move on to the next chapter called comments. So in C++ program Commits are user-written statements that are included in every C++ code for explanation purpose. These commits help anyone reading the source code. All programming languages allow some kind of commits. C++ supports both single-line commits and multi-line commits. Let us see how does these commits work. So this is our basics first hello world program. Now let us try to add single-line commits here. To add single-line commits, you need to type in 2 forward slashes. After that, you need to type in your message. So here, let me type in single-line commit. So this is how the single-line commits work. Now, let us try to deal with the multiple line commits. To write in the multiple line commits, you need to replace the forward slash with an asterisk. So here, the lines from hello world written and the closing bracket, everything is commented. In order to close the multiple line commit, you need to end the commit with asterisk and forward slash. This is how the multiple line commits end. So these are the ways to declare multiple line commits and single line commits in your C++ program.
Let's take up another quiz question. What is the correct way to declare a namespace in C++? Options are given on the screen, and if you know the answer, please leave it in the comment section below.
Now with this, let us move on to our next chapter, that is about data types used in C++ programming language. So the 3 basic data types used in C++ programming language are derived data types, built-in data types, and finally the user-defined data types. First, let us deal with derived data types. So some of the examples for derived data types are arrays, pointers, function, reference, and many more. Let us deal with each one of them in detail. Firstly, let's deal with arrays. So what is an array? An array is defined as a collection of similar type of data items stored in continuous memory locations. The array is the simplest data structure where each data element can be randomly accessed using the index number or the address number. So in C++ programming language, we have 3 different kinds of arrays. They are one-dimensional array, two-dimensional array, and multi-dimensional array or JART array. So let's see each one of them. Firstly, let us understand one-dimensional array. So, one-dimensional array can be defined as an array with single row and multiple number of columns. So the elements in one-dimensional array are accessed using their index numbers. Now let us understand the terminology of one-dimensional array. For example, consider that you have declared an array of size 5. So what the compiler does is, it will select one bigger block of memory, then divide the block of memory into 5 different parts, and those 5 blocks will be allocated to the one variable which is none other than your array variable. So here I have selected my array variable to be my array, and now compiler has given me 5 continuous blocks of memory to store integer type of data because my array is integer type and I have reserved 5 blocks. Now let us try to store some data into my one-dimensional array called my array. So firstly, I'll select 10. So the element 10 will be stored in the first memory location of the array, which is 0. Always remember, the array starts from the memory location 0. Followed by that, we shall add in few more elements, which are 20, 30, 40, and 50. So the data is been allocated into the array in a continuous format. So this is how the one-dimensional array works. Now let us execute a simple example to understand one-dimensional arrays in a much better way. So this particular example is based on one-dimensional array. I have declared my array variable as ARR and I'm trying to store 5 elements into my ARR array. Let us execute this program and see how does it work. You can either choose execute and compile and run option, or you can just press F11 as a shortkey to compile and run your program. You can see my program has been successfully executed and I have the output here. As you can see, I have successfully included all the elements into my array and I tried to print out one particular element from my array which is at the array index number 3. So in the array index number 3, we had 4 and that was the one which was displayed on our terminal. Now with this, let us move on to the next type of arrays, which are the two-dimensional arrays. The two-dimensional array can be defined as an array of arrays. The 2D array is organized as matrices, which can be represented as the collection of rows and columns. The elements of an array are accessed using their intersection coordinates. Now let us understand how do they work. Here let us consider our array as array. So array or array is my array variable's name here, and I have declared an array with 2 rows and 5 columns. Now let us try to insert an element into the array. So I'll select first element as 10. You can see the intersection coordinates as 0, 0. So 0, 0 happens to be the first memory location of my array here. So the 10 element will be stored in the first memory location. Followed by that, let us include few more elements into my array now. So we have 20, 30, 40, 50, 60, 70, 80, 90 and 100. So all these elements will be allocated into my array in continuous memory locations based on their coordinate numbers. So let's see how does it happen. You can see they are arranged in a sequential manner. So 20 is at 0, 1, 30 is at 0, 2, and finally 100 is at 1, 4. Now to access these elements, we have to provide their index numbers or the intersection coordinates here. Now let us execute a simple two-dimensional array example to understand them in a much better way. So this is the basic example for two-dimensional array. So here my array name is test and I have provided 3 rows and 3 columns. So the elements that I am going to enter into my three-dimensional array are 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we have 2 for loops here. So first for loop will be for the rows and the second for loop will be working for the columns. Now let us try to execute this program and see how does it work. You can see that the elements have been successfully included into my array along with their intersection coordinates here. So 0, 0, which happens to be the first memory location, saves my first element 1, and 2, 2 happening to be the last memory location saves my last element 9. So now with this, let us move on to the next type of arrays, which are the multi-dimensional arrays or also called as JART arrays in C++. So the multi-dimensional arrays can be defined as an array of arrays. The 3D array is organized in the form of a 3D matrix, which can be represented as the collection of multiple rows and multiple columns. The elements of the array are accessed using their 3D intersection coordinates. So here we have a vertical column, horizontal row, and another row which is in perpendicular with the horizontal row and the vertical column. Now let us execute a simple program to understand its terminology. In this particular program, we are going to enter 12 different values manually, and the name of my array is test, which has 2 rows, 3 columns and 2 rows which are perpendicular with the rows and columns. Now we have 3 different for loops here. First one will be for the rows, second one will be for the columns, and third one will be for the row which is in perpendicular with the row and column. Now let us execute this program and see how does it work. Don't worry about the codes, you can mail us for them at any time and we will reply you as soon as possible with the codes you need. Now let us enter 12 different values. Let me enter 1 to 12. As you can see, all my 12 elements have been included into the array from 1 to 12. 1 being located at the first memory location, which is 0, 0, 0, and 12 is located at the last memory location, which is 1, 2, 2. So this is how the multi-dimensional arrays work.
Let's take up another quiz question. Which of the following is a valid identifier in C++? And the options are option A, 1 variable, option B, variable underscore 1, option C, variable hyphen 1, or option D, variable space 1. If you know the answer, please leave it in the comment section below.
Now with this, let us continue with our next part of the session, which is related to the linked lists. So what are lists? Lists are the linear data structures completely similar to that of arrays, but the only difference is that the elements are not saved in a sequential memory locations as we used to do in arrays. Instead, they are sorted in random addresses and connected using pointers. So we have 3 different kind of linked lists in C++ similar to C, which are singly linked lists, doubly linked lists, and circular linked lists. Firstly, let us understand the working terminology of lists. Here, we will be having a random memory heap in our computer system. So what exactly happens is, if you want to store 5 different elements into your list, then the computer will select 5 random blocks from the memory heap. So here you can see that we have 5 random blocks from the memory heap with different addresses. First one is 1001 and the other one is 1023, then 3026 and 4537 and finally 7328. Remember the last block here. There is something happening here when we store the elements into the linked list. Now let us store the elements. You can see that 10 is allocated to the first one, 20 to the next one, 30 to the next one, 40 and finally 50 to the last one. The change happened here is the last memory location is allocated to null. This means that this is the end of the list. So here, how are they connected now? These are the addresses. So every block has a different address. So what compiler does is, it will connect this block with this block, where this block will be pointing to the address of this block. So actually, this particular address is not the address of this memory block. This particular address is the connecting address of the next memory block. So similarly, you have the address of the next connecting memory block here. This is how the linked list works and they get interconnected with each other. Once the linked list is complete, then we have the head node and the tail node. Once the linked list is complete, all the blocks are considered as nodes. Firstly, we have the head node, which is the starting part of the linked list, and at last we have the tail node, which is called as the ending part of the linked list. Now let us deal with the types of linked list. We have 3 different types of linked list in C++. Firstly, we have singly linked list, then we have doubly linked list, followed by that we have circular linked list. Now let us understand the terminology of singly linked list. So this is singly linked list. Singly linked list contains 2 different fields, namely the address of the next node and the data assigned to the present node. So this particular node is known as the head node, and this is the address block which is pointing to the next upcoming node. So here we have the head node where the memory is being stored, and this is address block where the address of the upcoming node is stored. Now let us execute a simple example to understand the terminology of singly linked lists. So this particular example is based on singly linked list. Now let us try to execute this. Once we execute, we'll be provided with 4 different options. First one will be for inserting elements into the linked list. Second one will be to delete the elements from the linked list. And third one will be to display the elements in the linked list. And finally, we have the count for counting the number of elements in the linked list. Other than that, we can give a random input to exit the linked list. Firstly, let us insert. Now we have inserted 4 different elements into our linked list. Let us display the elements. We can select number 3 to display the elements. So you can see that we have 4 different elements, which are 1, 2, 3 and 4. Now let us try to delete the element number 4. Let us select option 2. Now the compiler is asking for us to give the position of the element. Remember, we had the elements starting from 0 in arrays, but in linked list, the elements start from 1. So to delete the element 4, we need to give the address 4. You can see the 4th element has been successfully deleted. Let us check out the elements remaining in the linked list. You can see that we are remained with 1, 2 and 3. Now let us try to count the number of elements in our linked list by providing option number 4. You can see that the output is 3. Now let us try to exit our linked list. We are done. Let us try to understand the next type of linked list, which are the doubly linked lists. So doubly linked list is completely similar to singly linked list, but the only difference is it is traversable in both directions. When you come back into the singly linked list, you can see that you can traverse from head to tail, but not from tail to head. The singly linked list can travel in only one direction, but not in 2 directions. But when you come into the doubly linked list, you can travel in both the directions, starting from head to tail, and you can also come from tail to head. So this is the speciality of doubly linked list. The doubly linked list has 3 particular blocks. One to store the address of the previous block, and the one to store the memory, and the last one to store the address of the upcoming node. So this is how the doubly linked list work. To understand this in a much better way, let us execute a simple example. So this particular example is based on doubly linked list. Now let us execute this. As you can see, the program has been successfully compiled, and now the system is asking for 4 different options. 1. To insert elements into the linked list. 2nd, to delete the elements. 3rd, to reverse the linked list. And finally, the 4th one, to exit. Now let us try to add in some new elements. As you can see, we have inserted 5 different elements into my linked list, which are 10, 20, 30, 40, and 50. Now let us try to delete one element from our linked list by providing option number 2. Enter the element to be deleted. Now let us delete 30 from our linked list. You can see the element 30 has been eliminated from our linked list, and we remain with 10, 20, 40, and 50. Now let us try to reverse the linked list. So let us select option number 3. After reversing, you can find that the elements have been completely reversed from 50, 40, 20, and 10. Now let us try to exit the program. So this is how the doubly linked lists work. So with this, let us move on to the next type of linked list, which are the circular linked lists. There is no much difference between the circular linked list and the singly linked list. But the major and one and only difference is that in singly linked list, the tail node had the address of null. But here, the tail node is pointing back to the head. So this is how the list gets connected with each other, and it behaves like a circular linked list. Now let us execute a simple example to understand its terminology. So this particular example is based on circular linked list. Now let us execute this program and see how does it work. You can see that the program has been successfully executed, and we have the output here, and it says the circular linked list created is as follows, which is 30, 20, 10, 40, 50, and finally the tail is getting back connected to number 30. So this is how the circular linked list works. And after that, we have also tried to eliminate the number 10 from our linked list. So after eliminating, we have 40, 50, 30, 20, and again it is connected back to 40. So this is how the circular linked list works. With this, let us move on to the next concept, that is about stack. So what exactly is stack? Stack is a linear data structure which allows a particular order in which the operations are performed. The order may be LIFO, that is last in first out, or FILO, which is first in last out. Let us understand this practically. So what exactly stack is? Stack is completely similar to that of array, but the only difference is to access the elements, we need to follow the terminology called first in last out or last in first out. So what is this? Let us understand this through this simple example. So here I have this sample stack named as my stack. This stack stores integer type of elements. So let me include my first element, which is 10. So what happens here is, in the same way that we saw in arrays, the element 10 will be stored in the first memory location of the stack, that is 0. Followed by that, let us try to include few more elements in the same way. We have 20, 30, 40, and 50. So these elements will be stored in sequential order in the same way which happened in arrays. Now, if you want to access the elements from the stack, then you need to follow first in last out procedure or last in first out procedure. For example, if you want to access the element number 10, then you need to exit 50, 40, 30, and 20 first from the array. Then you'll get the access to number 10. Let us see how does it work. Let us remove 50 first, then 40, then 30, then 20. And finally, you'll be able to access element 10 from the stack. So to access the element 10 from the stack, you need to eliminate all these elements first. So this is how the stacks work. Now to understand this in a much better way, let us execute a sample code. So this particular example is based on stacks. Let us try to execute this. As you can see, the program has been successfully executed, and the elements are same which we chose for our stack, which are 10 to 50. So my stack is having 50, 40, 30, 20, and 10 elements, and size of my stack is 5. And the top element is 50 as we chose in our stack. The first element which is on the top of the stack is 50. So we need to pop all these elements to access the number 10. So this is how the stacks work. Now let us move on to the next concept in our tutorial, which is none other than queues. So what is queue? A queue is a linear data structure which follows the particular order in which the operations are performed. The order is first in, first out. Remember, we had the order first in, last out in stack, and in queue we have first in, first out. Let us understand the terminology how queues work. Queue is also completely similar to that of stack, but the only difference is, in order to access the elements in stack, you need to follow a different order from stacks. In stacks, we used to follow first in, last out, but here you can use first in, first out. So let us see how does it happen. So let me store the element 10 in my queue. So the element 10 will be stored in the first location, which is 0, similar to that of stack. Let us include few more elements, 20, 30, 40 and 50. So my queue is full now, starting from 10, 20, 30, 40 and 50. So in queue, what we used to do is, to access the element 10, we were supposed to pop 50, 40, 30 and 20. But in case of queue, we can directly access 10, which is first in, first out. So to access 10, we can directly pop out the element 10 from the queue. Now next we can pop 20, then we can pop 30, followed by that we can pop 40 and 50. So this is how queues work. Now to understand this in a much better way, let us execute a small example. So this particular code is based on queues. Now let us try to execute this. You can see that the code has been executed and now it is asking for 3 different options. 1 to insert, 2 to remove, 3 to display and others to exit. Now let us try to insert elements into our queue. First, let me insert 10. Then 20. Now let us try to eliminate number 10 from my queue. To eliminate, I need to select the option number 2. So the first element which was removed from the queue is 10. Now if I choose 2 again, then the next upcoming element is 20, which will be removed from my queue. You can see 20 has been successfully removed now. So similarly, it removes 30. So this is how the queue works. Now let us try to display the elements present in my queue. So to display the elements, I need to select the option number 3. So you can see that I am remained with 2 elements which are 40 and 50 in my queue. Now let us try to exit our queue by providing option number 4, which is other than 1, 2, 3. This is how you exit. So now with this, let us move to the next part of our tutorial, which is functions. So what are functions? Function is a subdivided program of the main program that performs a specific predefined task. It can be reused, so this reduces code complexity. So the syntax for functions is return type, function name, and parameter list. So to understand functions in a better way, let us execute a sample code. So this particular example is based on functions. So what I'm basically trying to do here is, I've declared a function here by name sum, which will be performing addition operation. And in my main program, I'm trying to call the same function by the name sum. And I'm passing 2 different parameters here, which are 25 and 20. And I'm trying to add them up. Now let us try to execute this program and see how it works. You can see that the program has been successfully executed and we have the output here. So this is how the functions work. Now let us move on to the next part of our tutorial, which happens to be reference. So what is a reference? A reference variable is an alternate name for the original variable. You can see that I have provided a basic example here. I have declared a variable on the name hello, which is of integer type, and it stores number 1. And now here I'm trying to declare another variable by name world, which has an ampersand symbol here, which says that it is a reference variable. Now this particular reference variable is pointing to the variable hello, so it can access the data which is present inside my hello variable, which is 1. So this is how reference variables work. Now after this, we have the applications of reference variables. There are 2 ways in which we can access reference variables, which are call by value and call by reference. Now let's execute a sample program to understand this application. So this particular example is based on reference. This is the first way of applying reference in a C++ program. This is by call by value. So let's execute this program and see the output. You can see the program has been successfully executed now. After this, let's try to execute the same program in call by reference manner. Now we are going to try to execute the same program in call by reference manner. Now let's try to execute this. You can see that the program has been successfully compiled and we got the output. Now after the reference, we shall move on to the next concept, that is about pointers. So pointer in C++ is a variable which stores the address of another variable. This variable can be the type of int, char, array, function, or any other pointer. The size of the pointer totally depends upon the architecture. So the pointer in C++ language can be declared using the asterisk symbol. So here you can find an example, int n is equals to 10. Followed by that, we have the pointer variable of integer type, which is declared using the asterisk symbol, and it stores the address of my first variable n. So this is how the pointers work. Let us execute one simple program to understand pointers. So this particular program is based on pointers. Now let us execute it. You can see that the program has been successfully executed and the address of pointer is shown here and the value stored in the variable is also shown. Now let's move on to the next concept. So the next concept is based on strings. So what are strings? The string is defined as one-dimensional array of characters terminated by a null character. The character array or the string is used to store text such as words or sentences. Each character in the array occupies 1 byte of memory and the last character must always be 0. So we have two types of strings which are char array and string literal. Now let us execute an example to understand strings. So this here is an example for strings. Here I'm trying to print two different messages which are hello world, welcome to Edureka, happy learning. Now let us try to execute this program. So here we go. We have hello world and welcome to Edureka, happy learning printed here. Followed by this, we have some important string functions in C++, which are string length, which describes the length of the string. Followed by that, we have string copy, which copies one string from a source to another destination. Then we have a string concatenation, which is used to join two different or more strings. Then we have a string compare, which compares given two strings. Then we have string reverse, which reverses the given string. String lower and string upper. The string lower converts the text from uppercase to lowercase, whereas the string upper is vice versa. Now let us try to execute all these string functions in one single program. So this particular example is dedicated to execute string functions. So we'll consider string copy, string concatenation, and string length. So our strings are Edureka, happy learning, and the last string 3 is completely empty. Now we'll try to execute this and see how does it work. So firstly, what we did is copying the string 1 into string 3. That is, string 1 had Edureka, and now this memory is been copied to string 3. Later, we have string concatenation, where we try to concatenate two strings that are Edureka and happy learning. And finally, the Edureka happy learning result is stored into the first string, that is str1. Now we will find out the length of str1, which happens to be 22. So this is how string functions work. Now followed by that, we shall move on to the next topic, which is the built-in data types. So the built-in data types available in C++ programming language are as follows. They are char, signed char, unsigned char, short int, signed short int, unsigned int, signed int, unsigned int, long int, signed long int, unsigned long int, float, double, long double, and W character T. So they are mentioned along with their bandwidth and typical range. Followed by this, we have the user-defined data structures. The first one amongst the user-defined data structures is the structure. So what is a structure? So structure is defined as a user-defined data type available for C++ that allows to combining data items of different data types together. Structures are used to represent a record. Struct is the keyword which is used to declare structures. So this here is a basic example of structures where I have used struct keyword and my structure name is school. So my structure is saving integer data type, which is ID of a student. Then followed by that, we have a string data type, which happens to be the name of the student. And lastly, I have float data type, which happens to be the percentage of that particular student. Now, let us consider executing an example to understand structures in a better way. So this particular program is based on structures where point happens to be my structure. Now let's execute this and see how does it work. You can see that the program has been successfully executed and the output has been printed here. Now let us move to the next part of the user-defined data types, which is enumeration. So what is enumeration? Enumeration in C++ is a user-defined data type. It is designed to assign names to an integral constant. The names increase the readability of the program and also the program becomes very easy to maintain. Enumeration is completely similar to that of structure, but the only difference is whatever the data you save in an enumeration using the keyword enum, then the value stored in that particular enum will be constant. You cannot remove the elements from enum, but you can add in some new elements to the enum. Now let's execute a simple program to understand what exactly enums are. So this particular program is based on enums, where my enum name is week. The days of a week start from Monday to Sunday and all these values stored are constant. You cannot remove any values from this particular enum, but if you want to try to add in some more, you can add. But in this particular context, you cannot add more days to a week, but in some other context, you can add in some more. Now let's try to execute this program. So this is how the enum works. Now what I've tried to do is to display the location of the day Wednesday. So this starts from 0, 1 and 2. So the location was 2. That's what displayed in the terminal. Now let's move on to the next part where we deal with a class. So a class in C++ is actually a user-defined data type. It's declared with a keyword class at the side of its members with personal, protected or public access specifiers. By default, all the members of a C++ class are private. Now let's execute a simple program to understand classes. So this particular example is based on classes. So here, student happens to be my class, and inside that I have provided two different data types. One is integer type, which stores the ID of the student, and the other is string type, which stores the name of my student. And inside my main program, I have a constructor named student. Then using this constructor, I'll be trying to input the data into my class. So now let's try to execute this and see the output. You can see that the program has been executed successfully and the roll number and the name of the student are being successfully printed here. So this is how the classes work in C++. Followed by that, we have a union. So what is a union? Union is completely similar to a structure in terms of declaration and usage, but all the members of a union occupy the same space in memory. That is, the same memory location is shared among all the union members. Now let's try to execute a sample program to understand how unions work. So this particular program is based on unions. Now let's try to execute this and see how does it function. You can see the code has been getting compiled and the output has been successfully generated, and we have the output here where A is 5, A is 10890511034 and B is 7.3. So basically what I have done here is I've declared a union, and inside the union I've declared variable A and variable B, which are of different types, integer and float respectively. And inside my main function, I've tried to do some operations upon these variables, and the results of those operations are being displayed here. So with this, let's move on to the next segment where we'll learn about variables used in C++. So variable is defined as the reserved memory space which stores the value of a definite data type. The value of a variable is not constant. Instead, it allows changes. So in C++, we have different types of variables which are as follows: local variable, global variable, static variable, automatic variable, and external variable. So firstly, let's understand local variable. So any variable that is declared inside the code block or a function and has scope defined to that particular block of code or function is called as a local variable. So for example, here I have void Edureka, which happens to be my function, and inside this function I have declared a variable on the name local variable. So this particular variable is storing the value 10, And now the scope for this particular variable is confined to the function Edureka. This means the local variable is not capable enough to be accessed outside the function Edureka. So this is how the local variables function. Followed by this, we have the global variable. So what is a global variable? Any variable that is declared outside the code block or a function and has scope across the entire program and allows any function to change its value is known as global variable. So basically, the global variables are declared outside all the functions and before even the main function is started. By doing this, the programmer will be capable enough to access the global variable from any function or any method and even from main. And all the functions including the main method can change the values which are present in the global variable. Here, I have declared a global variable of integer data type and it is saving the value 10 inside it. And you can see that the global variable is declared outside the Edureka function. So now I can access this global variable from my function or my main function and change its value after applying any particular operation on global variable. So this is how the global variables work. Followed by this, we have static variables. Any variable that is declared using the keyword static is known as a static variable. Static variables retain the declared value throughout the entire execution of the program and will not be changed between multiple function calls. Here you can see that I have used the static keyword. Followed by that, I have provided a data type which is integer and I have declared my static variable which stores the value 10. Now this particular value 10 will not be changed even after you apply any kind of operations onto this particular static variable. So this is the functionality of static variable. Followed by this, we have the automatic variable. So the automatic variables can be declared using the keyword auto. By default, all the variables declared in C++ language are automatic. Followed by that, we have the external variable. External variables are declared by using the keyword extern. We can share a variable in multiple C++ source files by using the external variable. For example, I have declared a variable by the name external which is of integer data type and I have stored 10 inside that variable. And we need to concentrate that I have declared this particular variable using the keyword extern, which makes this particularly an external variable. An external variable is also called as a global variable. Now after this, let's check out some rules for declaring variables. The rules for declaring variables are completely similar to that of identifiers, which say a variable can have alphabets, digits and underscore. A variable can start with an alphabet and underscore only. It can't start with a digit. Followed by that, no white spaces are allowed within the variable name. And the last rule is that a variable name must not be any reserved word or a keyword. Example, integer, float, etc. Now let's see some examples for valid variables names. First one is integer a, which starts from an alphabet, so it's valid. Followed by that, we have another one which is of integer data type and it's starting with underscore. So this is valid. Followed by that, we have integer a30, which is also valid because it's starting from an alphabet and it is continuing with a number, which is valid. So now let's check out some examples for invalid variables. Firstly, you have integer 2. So this particular variable is starting with a number which happens to be 2. So it's invalid. Followed by that, we have another example where we have declared int a space b. So this particular variable name includes space. So spaces are not allowed to be declared for variables. Followed by that, we have int long. So we cannot use long because long happens to be a data type and a keyword in C++, so it's invalid.
Let's take up the quiz question. Which keyword is used to define a constant variable in C++? And the options are option A const, option B constant, option C final or option D static. If you know the answer, please leave it in the comment section below. Now that we have covered identifiers, keywords, white space and basic data types in C++, we will now explore how modifiers, type qualifiers and operators enhance program functionality.
Now let's begin with our next topic, modifiers. So what are modifiers? So the modifiers in C++ allow the character, int and double data types to have modifiers preceding them. A modifier is used to alter the meaning of the base type so that it more precisely fits the needs of various situations. The data type modifiers available in C++ are signed, unsigned, long, short. Now let us execute a simple example to understand how exactly modifiers function. So this particular example is based on type modifiers where I have declared two variables of short int I and short unsigned int I. So j is storing the value of 50,000 and I is declared is equals to j. So when it's modified into unsigned int, the value will be changed. Now let's check out this. You can see that the program is getting compiled and the output has been displayed here. The modified value is minus 15,576 and the actual value which we have given to the unsigned int was 50,000. So the original value was 15,536 with this symbol minus. Let's move on to the next topic, which is based on type qualifiers. So the type qualifiers provide additional information about the variables they precede. There are three different type qualifiers present in C++ language. They are const, volatile, and restrict. Let's understand each one of them in detail. Objects of const type cannot change the program during execution. Next we have volatile. The modifier volatile tells the compiler that a variable's value may be changed in different ways, not explicitly specified by the program. Then finally we have a restrict. A pointer qualified by restrict is initially the only means by which the object it points to can be accessed. Only C99 adds a new type qualifier called restrict.
Here's another question for you guys. Which modifier is used to indicate that a variable can hold values larger than its default range in C++? And the options are option A short, option B long, option C unsigned, or option D signed. If you know the answer, please leave it in the comment section below.
Now with this, let us move on to the next topic, which is about operators in C++. So we have different operators supporting in C++. They are arithmetic operators, increment or decrement operators, assignment operators, relational operators, logical operators, and finally the bitwise operators. Firstly, let us understand about the arithmetic operators in C++. Arithmetic operations are used to perform mathematical calculations such as addition, subtraction, multiplication, division, and modulus. Followed by that, we have the increment or decrement operators. The increment or decrement operators are used to increase the value of a variable by specific number, and similarly, decrement operator is used to decrease the value of a variable by a specific number. Now let's move on to the assignment operators. The assignment operator in C++ is used to assign the values to a particular variable. For example, equals to and double equals to. Int a is equals to 10 is the simple example for assignment operators. Then we shall move on to relational operators. The name itself indicates the operation of this particular operator. The relational operator is a programming language construct or operator that tests or defines the relationship between two entities or variables. So the basic examples for relational operators are greater than, less than, equals to, not equals to, and few more. Then we have logical operators. These operators are used to perform logical operations on given expressions. There are three logical operators supporting in C++ language. They are logical and, logical or, and logical not. Finally, we have the bitwise operators. These operators are used to perform bit operations. Decimal values are converted into binary values, which are a sequence of bits, and bitwise operators work on these bits. So the bitwise operators supporting in C++ language are bitwise and, bitwise or, bitwise not, XOR, left shift, and right shift.
Now let's take up the another quiz question. What does the plus plus operator do when applied to a variable in C++? And the options are decreases the value by 1, increases the value by 1, multiplies the value by 2, or divides the value by 2. If you know the answer, please leave it in the comment section below. In our previous module, we explored modifiers, type qualifiers, and operators. Now, we will discuss control flow and conditional statements and loops.
So what are control statements? Control statements enable us to specify the flow of program control. They specify the order in which the instructions in a program must be executed. They make it possible to make decisions to perform tasks repeatedly or to jump from one section of the code to another. So the following are the control statements in C++ programming language: if statement, if else statement, if else ladder, nested if, switch, and break. First, we shall learn about if control statement. If control statement in C++ is defined as a programming conditional statement that, if proved true, performs an operation and displays the information inside that particular statement block. Let us understand the flowchart of if control statement. Basically, the control begins by executing the beginning parts. So after executing the start part, it enters or encounters the first condition. If the condition happens to be true, then the control enters the condition and executes the statements provided in that particular condition block. If false, the control first executes the start blocks, then it encounters the first condition. This condition is none other than the if condition. If the condition is true, then the control enters the condition and executes the statements which are present inside the condition block. In case if the condition fails, then the control flows outside the condition and executes the statements which are present outside the condition block. So this is how if control statement works. Now, let us try to execute a sample program to understand the functionality of if control statement. So this particular example is based on if conditional statement. So here I have declared a variable a which stores the value 100. So the if condition is if a is less than 200, then this particular statement should be executed. Else, only one particular statement which is outside the if block should be executed. Now let's run this program. You can see that the program has been successfully executed, and since the condition is true, this particular statement, which is a message which says a is less than 200, is been printed in the terminal. So this is how the if statement works. Now let's move to the next type of conditional statement, which is if else control statement. So the if else control statement in C++ is defined as a programming conditional statement that has two statement blocks over one condition. If proved true, then the if block will be executed, and if false, then the else block will be executed. Now let's check out the flow diagram to understand its functionality. So firstly, the start block will be executed as usual. Followed by that, we have an if condition. If the condition is true, then the control enters the if condition and executes them. If false, then the condition enters the else statement and executes the else statements. Once after either of the statements are executed, the control flows outside the if or else block and executes the statements which are present outside those blocks. This is how the if else conditional statement works. Now we shall execute a sample program to understand it in a much better way. So this particular example is based on else if conditional statement. Now let's execute it. You can see that I have given a is equals to 100 and b is equals to 200. In case if b is greater than a, then if block should be executed. Else, an else block present after the if block should be executed. Since b is less than 200, the first if block is executed here. Now let's move on to the next type of control statement, that is the if-else ladder control statement. The if-else ladder in C++ language is defined as a programming conditional statement that has multiple if-else blocks. If any of the condition is true, then that control will exit the if-else ladder and execute the next set of statement. Now let's see the flowchart to understand if-else ladder in a much better way. So here, the control begins at the start statements. After that, it has a set of conditions provided in here, starting from the condition 1, condition 2, condition 3, followed by that, we have the last condition, which is the condition n. So what exactly happens here is, the control checks for a valid condition. If condition 1 is true, then the statements in the condition block are executed and it leaves the block. If in case the condition 1 fails, then the control will flow to the upcoming condition and the condition is checked. If in case true, the statements are executed and the control leaves the block. In case if all the controls fail, then it reaches the last condition and checks for the valid statement. If the statement is valid, then that particular statement will be executed. Else, the control will skip all the if statements and finally execute the last statements which are followed after the if-else ladder block. So that's how the if-else ladder works. Now let's see a practical example to understand its functionality in a much better way. So this particular example is based on else if ladder. So here I will be entering the score of a student. So in case my score lies between 90 and 50, then my grade will be A. In case my score lies between 50 and 35, then my grade will be B. In case it is less than 35, it's supposed to be C. And if it is invalid score entered by the user, then it is set as failed. Now let's try to execute this program and see how does it work. You can see the program is getting compiled, and now I'm supposed to enter my score. Let us enter 90. You can see my grade is A, which is printed here. Now with this, let's move on to the next type of control statement, which is the nested if control statement. So the nested if control statement in C++ is defined as a programming conditional statement that comprises another if statement inside the previous if statement. Now let's see the flowchart to understand this functionality in a better way. So here, the control begins at start block and executes the first outer if statement. If the condition is true, then the control enters inside the if block where it encounters another if statement. In case if the control sees the condition fails, then it will exit as it is. Now we shall assume the condition is true. Once after the control enters the second if block, it checks for the second condition. If it is true, then statements will be executed. Else, the else statements will be executed. So this is how a nested if statement works. Now let's try to execute a simple program to understand nested if statement. So this particular code is based on nested if statement. Let's try to execute it. Before that, you can see that the outer if has A is equals to 100. In case if A is equals to truly 100, then it enters the if block and the next if condition is checked. In case if it is false, then the control will directly exit the outer if block and execute the two out statements which are present outside the if block. Now let's try to execute this. You can see that the outer if block failed, so the statements present outside the conditional block have been executed here. Now with this, let's move on to the next type of control statement, which happens to be the switch control statement. Switch case in C++ is defined as a programming selection statement that checks for a possible match to the provided condition against the available cases. If none of the cases match, then the control will execute the default statement block. This is similar to else if ladder. Now let's check out the flowchart to understand this in a much better way. So here, the control will first enter the switch expression and checks the condition. If the condition matches with case 1, then the statements inside the case 1 will be executed and the control leaves the switch block. Similarly, if the case 1 fails, then it checks for the validity in case 2. If case 2 finds a match, statements 2 will be executed and exits the switch statement. In case if case 2 also fails, then case 3 is checked and statements 3 will be executed. And finally, it will exit the switch statement. In case if all the cases fail, then there is a default statement in switch expression which will be executed, and after that the control leaves the switch case. So this is how the switch case is been designed to work with. Now let's execute a sample program to understand this in a much better way. So this particular program is based on switch control statement. We have 3 cases inside here, and I have provided one particular choice, which is 3. If case 3 is matched, then the message inside the case 3 should be printed. Now let's execute this program and see the output. You can see that case 3 found a match and the message inside the case 3 block has been executed here. Now with this, let's move on to the next part of our tutorial, which happens to be the break statement. The break statement in C++ programming language is defined as a programming conditional statement that is designed to exit the control from the current code segment to the next code segment when a specific condition is satisfied. Now let's check the flowchart. Firstly, the condition is checked. The control checks the condition, and if it finds the condition is valid, then very next the control flow from that particular block of code will be blocked and the control takes an exit. In case if the control finds the condition to be invalid, then the same condition is continued for one more time. So this is how the break control statement works. Followed by this, let us continue with the loops in C++ program. So what are loops? Loop control statements in C++ are used to perform looping operations until the given condition is true. Control statements come out of the loop statements once the provided condition becomes false. So there are 3 different types of loops in C++ programming language. They are do while loop, and for loop. Let us understand each one of them in a much better way. Firstly, we shall deal with the for loop. The for loop can be defined as a precise loop which has initialization, condition, and increment or decrement operator. So the for loop has three different parts. Firstly, initialization comes in the first position. Later, we have the condition provided by the user. Then we have a valid increment or decrement operator. Now let us check out the flowchart to understand the functionality of for loop. The control begins at the initialization state, and once after the initialization is done, then the control checks the condition. In case if the condition is true, then the statements inside the for loop will be executed, and once the statements are executed, the control flows into increment or decrement operator and performs the operation of increment or decrement as per the user's request. Once after the process is done, then the control will again enter the condition and checks the condition's validity. If the condition is valid, then it enters the loop again. In case if the condition is false, then it will exit the for loop. This is how the for loop works. Now let's try to execute a program to understand the working condition of for loop. So this particular example is based on for loop. So here I've provided the initialization variable as I is equals to 1. Followed by that we have the condition which says that I should be less than or equal to 10. And lastly, I've provided the increment operator. Now let's try to run this program. You can see that the program has been successfully compiled and the numbers starting from 1 to 10 are being printed here on the terminal. So this is how the for loop works. Followed by this, let's deal with the nested for loop. The nested for loop is completely similar to that of the for loop, but the only difference is the external for loop includes an inner for loop. Let's check the functionality. The control begins at the start statements. Firstly, the outer for loop is executed. In case the condition fails, the control exits. In case the condition is true, then it encounters the inner for loop. If the control finds the condition in the internal for loop is true, then it executes the internal for loop, else it exits. So this is how the nested for loop works. Now let's move on to the while loop. While loop can be defined as a loop which executes itself repeatedly until a given Boolean expression or a condition is true. Now let's check out the flow diagram. The control begins at a decision. In case if the decision is true, the statements inside the while loop will be executed, else the loop will be terminated. Now let's try to execute a simple program to understand the functionality of while loop. So this particular program is based on while loop. Let's try to execute it. The program should be working for generating factorial numbers of the given number. Now I have inputted 10. Let's generate the factorial numbers here. We have the factorial number of 10 as 3628800. Now let's move on to the next type of loop, which happens to be do while loop. The while loop and do while loop are completely similar to each other, but the only difference is the condition block will be placed at the end of the while loop. So here the control begins at the execution of statements first. Once after the statement is executed, then the condition is checked. If the condition is true, then the statements will be executed again. In case if it is false, then the control exits the do while loop. Now let's execute a sample program to understand do while loop in a better way. So this particular example is based on do while loop. Now let's try to execute this. We can see that the program is getting compiled and the output has been generated here. The value of num from 1 to 6 are being generated here as per the condition provided here.
Let's take up the quiz question. What will the following code print? And the options are A, greater, B, smaller, C, error, or D, nothing. If you know the answer, please leave it in the comment section below. We have covered conditional statements and loops, which are essential for directing the flow of C++ programs. We will now dive into functions in C++ and understand their role in modular programming and efficient code management.
So what are functions? A function is a group of statements that together performs a task. It can also be defined as a set of statements that take some input and does some computation and performs an output or gives an output. Now, every C++ program has at least one function, which is main, from where the program actually begins. So a very simple or a very basic program could be a main program, which itself is a function. And inside function, you can have various statements to perform various operations, display messages. So all those are functions. So basically function is a collection of statements, and those statements which are enclosed in a function are executed when you run the program. In the function you have some inputs, you pass, a computation happens and you get an output. This is what is required to basically construct a function. Now what are the types of functions? Function can be categorized into two types. One is library function and another is user-defined functions. So library functions are declared in C++ header files such as ceil, cos, exp, etc. So these are some of the inbuilt functions which are provided in the C++ libraries. You can simply call the function by passing the necessary argument to those functions. Another type are user-defined functions. These functions which are created by C++ programmers in order to use it repeatedly. So for example, if you want to find the sum of two numbers, or if you want to find the maximum of two numbers, or practically any kind of operation that you want to do repeatedly, what you would do is that you would basically create a function and call that function instead of having to write that piece of code again and again. So that is known as a user-defined function. Now, how do we do function declaration? C++ function declaration tells the compiler about the function name and how to call a function. So syntactically, this is how it looks like. So if you look at function, you give the return type of the function, you give the name of the function, and then you specify the parameters. Now the actual body of the function can be defined separately while using function definition. So we can define function body within the class or outside the class as well. Both options are available in C++. So moving on. So this is a typical syntax function definition. A C++ function definition consists of a function header, which is return type, function name, and parameters. So this is a return type, the name of the function, and the parameters that you want to pass, and the function body. So as you will see, the function starts with a bracket and ends with a bracket. These are curly braces, and whatever you put inside this function is known as the body of the function, which is executed when you actually call that function. So what is a function calling then? To call a function, we simply pass the parameters required along with the function name. So we will see this with an example shortly, but for now, let's continue with these points here. While creating a C++ function, we give a definition of what the function has to do. So generally, you should give name of function in such a way so that if you are performing a sum operation, you should call the function as sum. If you are trying to find maximum of two numbers, you should call the function as maximum, or max for that matter. Similarly, to use a function, we will have to call a function or invoke that function, which we'll see in some time with an example. When a program calls a function control is transferred to the call functions. So suppose I had a main program here. This is my main method. From here, if I'm calling a function, let's say there is a function sum. I'm not writing the complete syntax. So if this is a function sum, and inside this I have some statements. So when I call the sum method, what happens? The execution flow or the control is transferred to that particular method. So this is what is mentioned by this particular statement. Then next is a call function perform the defined task. So here the sum is the call function. It will perform the task that you have defined within the curly braces. When its return statement executed or when its function ending closing braces is reached, it returns program control back to the main program. So if you have this function, let's say I will erase this and let me create another braces here. Now there are two ways to return the control back to the main. Either you can have a return statement within this particular body and will return the control back to the main program, or once the end of the function is reached, or when it executes the statements which are in this particular body of that particular method. So that way the execution of the function has completed and the control will return back to the main program. So this is a very simple program where I'm writing a function to basically find the maximum of two numbers. So I have defined return type of the function. This is the name of the function. These are the two integer parameters which I'm passing. Here I'm defining an integer temp, and I'm saying if x is greater than y, then temp is x. That means it is maximum, or else temp is x, or else temp is y, and then finally return the temp. So basically here the parameter names are not important. I could have given here a and this could be b. The name of the parameter is not important, but the type is important. So parameter names are not important in function declaration, only the type is important. So I could have number 1, number 2, or a or b. So this is basically function definition, this part here, and this is the body of the function. So basically this is a small example of a function which is trying to find maximum of two numbers, in this case two integer numbers. So how do I now basically call that function from the main? I can now, as you will see, I have defined a as 100 and b as 200, and this is a return value or a temporary value which is stored, or rather it stores the value which is returned by the max method. So if I say return max of a comma b, so it will return the maximum value and that will get displayed here. So as you will see in the previous slide here, I had the max function. It returns the maximum of two numbers and that is getting stored in the return variable here, and that is getting displayed. I mean, in this case, the max of these two is 200. So we'll get the output as 200 here. So let us now try to understand how we create functions with the help of an example. I'm now connected to my lab VM. Here I have a main method which simply displays hello functions. So now let me create a function. We'll call it max function. So I'll say int max. Here I will say int x comma int of y, and I'll open the bracket and I'll close the bracket. Now I'll define a temporary variable which I'll call as int temp, and I'll say if x is greater than y, open bracket, close bracket. Now here, since x is greater than y and we are trying to find the maximum of 2, I'll say temp equals to x, else will say temp equal to y, and then I will return the value of temp. So here I'll say I'll return temp. Now if you will look at this program, let's understand it in a little bit more details. So for that, what I'm going to do is I'll bring my marker here, and this is the name of the function here. As you see, this is the return type of the function. These are the arguments you are passing to the function, and function start at this bracket and ends at this bracket, and this is the body of the function. The code which is inside, or the statement which is inside these two curly braces, is known as the body of the function. So let me clear all this now. Now how do we call this function? So for calling that function, I can simply say max and I can say 10 comma 20. Now since it returns a value, I can store it in a variable. I'll say int m equal to, and I'm storing it in int because it is returning an integer. This max is returning integer type, and then I can say cout. I can display the value of m, and then I can say endl. Now if you want, you can also put some message here. The maximum value is, max value is. So let's try to run this program. So I will go to build, I'll go to run, and I'll say build and execute. And here in this window, let's go and see the output, which is max value is 20. So out of the two value 10 and 20 which we passed, it displays the value as 20, as you can see from here. If you change the values, it will still display the maximum of two values. Now here I have passed two constant variables. You can as well do it like this. You can say int a equal to 10 maybe, and then you can say int b equal to 20, and you can then pass a comma b as well. So that is also perfectly fine, a comma b here. So this basically is going to work in the same way as having passed 10 and 20. So let us run this program again, run and build and execute. Let's go and see the output here. So you will see still the output is same. So basically what we have done is we have defined a function or a subroutine or a piece of code which can be used to perform similar kind of task over and over again. So if you want to find maximum of two numbers, number of times, 10, 20, 30 times, you don't have to write this whole logic or code again and again. So that is why we make use of functions. So this is a very simple example of functions, but you can have very complex and very large algorithms translated into a function in C++. So then what are some of the advantages of making use of a function? Now there are various advantages. Let us talk about those advantages. We achieve code reusability, we achieve code optimization, and code modularity. So code reusability, because we don't need to write the same code again and again. So suppose if you have to find the maximum of two numbers in multiple places in your program, so you do not have to write that logic over and over again. What you can do is you can take that logic, write it in a function, and just call that function by passing the arguments. So we are reusing the piece of code or a piece of functionality. Then we also achieve code optimization, which is we don't need to rewrite the same logic. I mean, it is like you have done or written an algorithm or a logic with some optimization done based upon various logic and computation that is involved in that particular function. Now you have achieved a level of optimization in that function or your algorithm. So you don't need to rewrite that same logic over and over again and test it. So you tend to achieve code level optimization as well. And then finally, we make the code modular, meaning that many lines of code is divided into functions. If you were not to write a function, let's say max function, and if you have to find maximum of two numbers, let's say 10 times, so you would have to write that logic so many times. As many times you have to find the maximum of two numbers. But by making use of functions, what you have done is you have achieved code modularity, or basically you have taken that many lines of code and put it into a function or a subroutine. So next, let us talk about what are functors in C++. It is not function, it is functors. So functors and functions are two different concepts in C++. It should not be confused. I mean, these are two different concepts and we'll try to understand what it is. So let's go through the points here. Functors are objects that can be treated as functions or function pointers. So basically the concept of functors is that when you treat existing function as some kind of an object in C++, it is a concept of functors. Functors are called using the same syntax as that of function, which I will show with an example in some time. And functors are mostly used along with STLs. STLs, which we have already studied in a different module, they make extensive use of functors. So let's try to understand this with a small piece of code here in the slide, and then finally we will look at the actual implementation of functors. So if you will see here, what I have done is I have written a function which is to find the square of x here. Now what I have done is I have defined an integer array with 5 elements, 1, 2, 3, 4, 5. Now I'm calling a transform function. This transform function is basically coming from namespace std. Now if you will Google and look at the documentation of transform, it is taking this argument, first iterator, last iterator, that is input iterator. This is the result and this is unary op. So basically I'm passing, this is the first value or the input iterator pointing to first element of data array. This is the pointing to the last. This is the actual data where the result will get stored. And this is the unary operation which we are performing. Now in this case, if you will observe carefully, that I am passing the square as an argument to this particular method. Here the method called is transform. So in this case, I am passing the fourth argument as a function, which is like treating the function as an object and passing it to the transform method in this particular case. So what will happen is this particular transform method internally will generate or evaluate the square of this number, this number, this number, this number, this number, and store the result in data. And after that, if you display the values, it is going to be 0, 1, 4, 9, 16. Because square of this is 0, 1, 4, 9, 16. Here the function square takes one argument. As you can see here, we can use this function as an object. So basically in functors, we make use of functions as objects to do the square operation on the set of data. So this is how we basically make use of the concept of functors in C++. So I'm on my lab VM, and now let us understand the concept of functor. So I have created a simple main method. It just displays functors for me for now. So as we had taken an example of square method in our slides, let's create a similar method. So I will say int square here, and I'm going to pass it as some int parameter, int x. You can give any name instead of x. Here I'm making use of x, and I'll say return of x into x. So this returns a square of integer x, and the return type is int here, right? Now what I'm going to do is I'm also going to define an integer array. So I'll say int data, and let me give it size 5 equals to open close braces, and I'll give it values maybe 0, 1, 2, 3, and 4. So I have given 5 values. Now what I'm going to do is I'm going to call a function transform, about which I have already explained to you in the slide. So I'll say transform. So if you look at the autocomplete feature here, it shows the first argument as iterator, second as an iterator, third as the, let's look at this one here. I will give here data. This is the first value or first iterator of beginning. This next one is data plus 5 comma. This is the data where we have to store the result, and finally square. So let me copy this and paste it here. So now in this case, if you will see that I'm trying to basically call this transform method with one of the argument as function, and it is being treated as an object. So as far as the arguments are concerned, I had already explained in the slide that this is input iterator to the first element to the last element. This is the result, basically the third argument, and this is the unary operator. So going back to the VM here, so this is first class, this is where the result is to be stored, and this is the operation, in this case unary operation, which I'm passing, and this is an object of the function square. And after that we will try to display the values. So let me display the values after this. So what I'm going to do, I'll say for in I equal to 0, I is less than, let's say 5 here, and then I'll say I plus plus, I'll open bracket and close bracket, and then I'll display Cout here data of, I'll say I, and I'll also put TNDL. So let us try to run this program and see the output. So before we can run this program, you will see that this is a method call, and these are the arguments we are passing. So we have to end this particular method call or statement with a semicolon here. I'll put a semicolon here and I'll run this program. I'll say build, I will say run, and then if you will say build and execute, let us go and see the output here. So you will see that it is 0, 1, 4, 9 and 16, which is the square of the numbers which are stored in the array. So we have basically treated this function as a functor. Functor is when you use function as an object. So this is how we make use of functors in C++. What is a virtual function? So a virtual function is a function which is defined in base class and then redefined with same signature in the subclass. It uses keyword virtual in the base or a superclass. So let's say I have a class here which is a base class, and I have one more class here which is a derived class, and D is inheriting the base class B. Now virtual function is a function that is called depending upon the object where the pointer is pointing to, rather than the type of reference, type or reference to the pointer. Now this we will see with an example, that if you have a pointer and if this pointer is pointing to whether object of D or whether object of B, that will determine whether virtual function or rather the function will get called from B or class T. We will see that with an example in some time. Now virtual functions are used to implement runtime polymorphism, where the call to the method is deferred till the program is running or executing. So because of this concept that a pointer is pointing to which object, whether it is an object of B or object of D, that is determined at runtime, and therefore which method will get called is also determined at runtime, and therefore it is known as runtime polymorphism. Now a function is declared virtual by using the keyword virtual in the superclass. So if you have a function fn, let's say we have to add a keyword virtual with this function, which we will see with an example in some time. Now when a function is declared as virtual in a class, all the subclasses that override this function have the function implementation as virtual by default. So this is a concept that you have to know of. So let's move on to the next slide. Now what is the need for virtual functions? So let us consider the following example to understand the need for virtual function. Now without the use of virtual function, we will get early binding. Which implementation gets called is decided at compile time. So basically what is early binding? So let's say if you again had a base class, and let's say you have a derived class here. Now this time I'm going to take as car, and this time I'm going to take BMW, and BMW is extending class car. Now whether a method from car is called or BMW is called, that determination can either be done at compile time or runtime. So let's say you go and buy a BMW, you would expect the method of BMW getting called instead if somebody buys a car or an ordinary car. Now whether when you are compiling the program, before you run this particular piece of code, you have to compile it. And during compilation, if the compiler knows that, okay, you have to call the method from car or from BMW, then it is known as early binding, which is determined at compile time. Whereas if you make use of virtual function, we get late binding, which implementation will get called is deferred till runtime. So whether you are going to call method from this or this will be determined at runtime. This concept is known as late binding, and this is a concept which is used for virtual functions. So let's move on to the next slide then. Now, what are some of the rules of virtual functions? They are always defined in base class and overridden in the derived class, but it is not mandatory to override in the derived class. So this is one of the rule of creating a virtual function, wherein you have to override it in the derived class, but it is not mandatory. Now the virtual function must be declared in the public section of the class, and then they cannot be static or friend functions. So static or friend functions cannot be virtual functions. So if you have to make a function as virtual, they should neither be static or a friend function. Then virtual function should be accessed using a pointer to achieve runtime polymorphism. So you cannot simply create a reference, and by reference you cannot just call them. And we will see with an example shortly that if you have to access them, you have to make use of pointers to achieve or implement the function of, or rather implement the concept of virtual functions. Now, before we actually look at coding implementation, let's try to understand what is binding. So binding for function means that there is a function call, or wherever there is a function call, the compiler needs to know which function should it be matched to. So let's say if you have a class A and it has a method m1. So if you say AA and then a.m1, you can call method like this. Now this is called binding, meaning that the compiler knows that for this particular object, this method is supposed to get called. So the compiler needs to know which function definition should it be matched to. Now this depends upon the signature of each function declaration and assignment that are taken. So whatever is the signature of this method and the type of arguments that you are going to pass to this particular method, all that is going to determine which function is going to get called or which particular method is being bound to this particular call. Also, the compiler needs to know when this matching between the function call and choosing the correct definition will happen. So when meaning whether it has to call M1 from superclass or M1 from subclass, it has to know whether it has to be done at compile time or runtime. So this is a concept of binding in C++ programming. So now let us try to understand with a small piece of code. Let's have a look at a small piece of code here and understand this. So first of all, what is early binding? Now, when the compiler is able to determine the call to method at compile time, it is known as early binding or compile time polymorphism. Now, although here you will see that I have an animal class from here to here, and there is a dog class which extends this particular animal. Now it has animal sound and it has also animal sound method. Now here I create a pointer and that points to an object of dog, and if I try to call animal sound, it is going to call me, or rather it is going to call. So the output, as you can see, although you have the parent class pointer pointing to instance of the child class, it invokes the parent class version of the function. So this is basically going to call this particular method here. So we will get an output as this is a generic function, for example. So this is early binding. And early binding meaning that during the compilation of the code, the compiler is aware whether it is going to call this method or this method. But in this case, it will call the method at one, and this is determined at compile time itself. So this is known as early binding. Now let us try to understand then late binding. In case of late binding, whether the method from super or base class will be called or method from sub or derived class will be called is determined at runtime or when the program is running. Now same example, animal, dog extending animal. Now here, if you will see, I have made use of a keyword virtual here, and the reference of object pointer of the type animal, but it is pointing to dog. So basically my reference is of type animal, but it is pointing to an object of dog. And when I say object with this notation animal sound, this time it is going to call this output, or woof will be displayed, which is the output from the subclass object. So basically, as I had explained earlier, that when you make use of a virtual function, as you can see here, the output which is displayed will be from the method where this pointer is pointing to. So this pointer, so if you think of this as a heap memory, this is an object of dog, and your obj is pointing to the object of dog, which is a subclass here, right? And therefore, this object will call the method from this subclass, which is this particular method. And this determination is done at runtime, or when the program is executing, that time it will come to know whether it is calling this method or this method. Whereas in the case of early binding, it was determined at compile time itself. So this is a concept of runtime polymorphism in C++. Now, so let us try to understand the concept of virtual functions with the help of an example. For that, I am using my lab VM. So before we actually look at virtual functions, this is a simple program. In this simple program, if you will see, I have a class here, my account, and I have a saving account which inherits my account. Now, the important point to note here is that I have a method here with the same name here as well as here. Return type is same here as well as here, and the argument is also same. Now what I'm going to do is, before we look at the virtual functions, let's do a regular implementation. So what I mean by regular implementation is that inside my main method, I'll create instance of this, for example, or rather, let's create a pointer. I'll say start and I'll say ACC1 equal to new of the same class. Now what this will do is this will create a pointer ACC1 which is pointing to an object of type my account, and this object is created in heap. Let me also create one more. I'll copy and paste it here, and I'm going to make it as 2, and I'll copy and paste this one here. Now let's call the methods, but before we do that, let's try to draw a diagram and understand this conceptually. So here I have an object of my account. This is blue in color, let's say, and I have another which is another color, right? And I have my ACC1 pointing here and ACC2 pointing here. Now let's go ahead and make calls to this particular methods in those corresponding objects. So what I'm going to do is I'll say ACC1 and then I'll say withdraw and I'll pass, let's say 100.5, and next what I'm going to do is I will say ACC2 and then let me make it 200.5. Now let us try to run this program and see the output. Now when I run the program, you will see that in both the cases the output is coming out as my account withdrawal, my account withdrawal. Now this value is coming from superclass or the base class here. So when we are making use of a normal function, when I say normal function, a function which is not virtual, I'm referring to as normal, then the method which will get called will depend upon the reference of this particular class. In this case, it is my account. So since my account has this method withdraw, in both the cases, it will call the method from this particular class. So this is a concept when we are not making use of virtual functions. Now let's do one thing. Let me clear all the drawing and now I'll make this virtual here. Now I'll make it virtual function. Now again, conceptually, I still have the same heap. I have object 1, object 2, wherein ACC1 is pointing here and ACC2 is pointing here. Now the change I have made is that I have made the function as virtual here. Now let's try to run this program and see what happens. So now in this case, if you will see, the output is different. In the first case, it is giving output from main or the base class, and in second case from the derived class. And why is that so? Because we had seen earlier in the discussion then when we are making use of virtual functions, which methods or rather which objects method will get called will depend upon where that particular pointer is pointing to. So in this particular case, ACC2 is pointing to an object of type saving account, and therefore it will call the method of this particular class saving account. And this determination, whether it will call the method from my account or saving account, this determination is made at runtime, and therefore it is also known as runtime polymorphism in C++. So this is how the virtual function works, wherein you put a keyword virtual. Now it is optional for you to put virtual here as well. You can put it, but it is not required. You can even leave it without this. So this is a concept of polymorphism or runtime polymorphism in C++. And this is how it works. Basically, the method here ACC2 is pointing to an object of saving account which is stored in a heap. So when we are calling the method withdraw, we'll call the method from the subclass and not from the superclass. Now let us understand the concept of what is an abstract class. Abstract class is defined as a class with one or more virtual functions. Now an abstract class are essential for providing an abstraction to the code to make it reusable and extendable. So let's understand this with an example. Suppose you have a shape class. Consider an example of shape class, which is a base class with subclasses triangle and rectangle. I have two subclasses that inherit the shape. Now the function will be declared in shape class. However, it cannot be defined there as the formula for the area is different for each type. So let's say I have a formula to find out shape or maybe find out area or find out perimeter or whatever it is. It will be different for maybe rectangle and for triangle also. So I don't want to give the implementation in the superclass, but I want to give it only in the subclass. But because it is a shape, it becomes mandatory for me to define a virtual function here for which I am going to provide definition in the subclasses. So this is a concept of abstract class. So a virtual function which is marked as having no implementation is known as pure virtual functions. So basically what we are trying to do is we are trying to create a function which is virtual in nature and which does not have any implementation. It is known as a virtual function. So let us see a coding example or a sample code for this particular concept. So if you will see here, what I have done is I have a shape class starting from here, ending here, and public access modifier. I have defined this function as virtual. Now it ends here. As you can see, this particular function does not have any body. This is known as pure virtual function. And then you have the normal method to set width, set height, and the protected members maybe. Now you have a rectangle which is extending the shape or inheriting the shape class. Now here, this particular method has been defined here, as you can see. It has been given body with open and curly braces. Here you can give, in case of rectangle, areas width into height. And in the case of triangle, you have a different formula. So as you can see that in case of abstract classes, you have a virtual function which has no body, and we give the definition of that in the subclasses. So function is declared to set width and height. These are normal functions. The implementation of area is specific to the rectangle and triangle. And the output for this will be as per. So now what I'm doing is I'm creating object of rectangle, triangle. I'm setting width, setting height. And now if I call this for rectangle, it will get called. This particular method or area method will get called, and it will display me the area for this particular rectangle, and similarly for triangle. So basically, in essence, what we have done is we have defined a abstract class. What is an abstract class? It is a class which does not, or rather I should say abstract class is a class which has a abstract method. And what is an abstract method? It is a method which has no body at all, and the definition of that body is given in the subclasses, which is inheriting that superclass. In this case, the superclass is a shape class. Now, so let us understand the concept of abstract classes in C++. So for that, I will go to my VM here and let us do some coding. So first of all, I will create an access modifier which is public : and here I declare a virtual function which is a pure virtual function like this, var virtual int. This is a return type, and I'll say AREA equal to 0. Now what I'm going to do is let's create one more class here. If you will see, before that, this does not have any body, right? This is a method which I have created without any body. Now let me create one more class. I'll say class rectangle, and I'll say : public of shape, open and close, end it with a semicolon here because it is a class. Now what I'm going to do is I'll again specify a public modifier, access modifier public : and here now I'm going to give body to this particular method in the subclass like this, open and close. Now you can perform any mathematical operation of your choice here, but in a simple scenario like this one, I'm just saying cout, COUT, and then I can say I am rectangle. So let me put this here, and then I'll say NL, and then now what I'm going to do is I'll go in my main. Here I will create instance of this particular class R, and then I'll say R dot area. Now let us run this program. So when I run this program, you can see the output is coming out as I am rectangle, which is coming from this subclass here, or the derived class. So basically what we have done here is, in this case, we have created a virtual method. It is purely virtual as it has no body. It is defined here, and then you create an object of that particular object and call the method. So as we had seen in the discussion in PPT, you could have a shape. Shape could be a rectangle, or maybe triangle, or maybe any other thing you want to have, maybe circle or any other kind of a shape. Now you have defined a virtual function area here, but the actual area evaluation for rectangle can be decided or defined here. Same way, triangle, it can be defined in the subclass here, and for circle it can be defined here. So basically this is how we make use of abstract classes in C++.
Having explored functions and their importance in C++ programming, moving forward, we will introduce classes and objects in C++, as well as the foundational concepts for object-oriented programming, such as encapsulation, inheritance, and polymorphism.
So let's begin the discussion with what is C++ classes and objects. So let us understand the concept with the help of this diagram in front of you or the slide in front of you. Now, class is a blueprint for an object. What does it mean? It means that when you construct a house, you create a blueprint which outlines the layout of the room, windows, and other things that are in the house. Similarly, when you are trying to construct an object with respect to C++ programming, you create a class. That class constitutes an blueprint or an outline of the object that is going to get created. So class has details like members of the class, which can be variables and functions. So based upon that blueprint, we construct an object. With this analogy, we will try to create class as a blueprint in C++, and finally, when we create an object from that class, that becomes the physical existence of that particular class. So let's try to understand this with an example in the next slide. So how do we define a class? In C++, a class is defined using keyword class. So as you can see, we have a keyword class here. This is my class here, followed by the name of the class. So this is the name of the class, employee. The body of the class is defined inside the curly braces. So if you start from here and you end here, the braces, and it is terminated by a semicolon here. So this is how you define a class in C++. So this is a syntax of creating a class in C++. Now then, what is a C++ object? C++ supports object-oriented programming, meaning that it allows you to divide complex problem into smaller sets by creating objects. So meaning that suppose you are working on a problem statement, you will divide that problem statement into individual entities or objects so that it is easy to understand and solve the problem. Now, an object is an instance of a class which can be used to access member variables and function of a class. We shall see this with an example in some time. So basically, object is a physical instance of a particular class that we are talking about. And the syntax to do that is you give the name of the class and the name of the object or instance. This is the syntax of creating an object of a class. So let's try to understand this in more details in the next slide. So for example, in the slide that you see in front of you, suppose we had a class called employee. So I can say employee E1 in the main method. So you can access the data members and member functions using a dot operator. So after you create an object of the employee class, you can say E1.display. So it is going to call the display method. This will call the display function from the class for the object E1. Similarly, if you want to access the member variable or rather an employee ID which is defined in a class, you can say E1.employee ID equal to 100. So basically we are assigning 100 value to this employee ID here for this particular object E1. Now take note that if it is private member of a class, we cannot access it outside the class. So regarding access, we have a different discussion and I'll talk in more details about that in access members or access modifiers of a class in CPP. So for now, let us focus on how we access the members, which is method and a variable of a given object. So if you look at this slide in front of you, you will see here that I have a class. I have two variables defined as public, which is a name and an employee ID, and I have a method here which displays those two values. Now this is a class and I'm creating an object of this one and trying to access the member. So let us go to our virtual machine and try out this example. So this is my lab VM. Let us try this concept of classes and object with an example here. So I have a simple main method here, which is not doing anything for now. What I'm going to do is I'm going to create a class and I'm going to call it as employee. I'll open bracket and close bracket and end the class with a semicolon here. Now what I'm going to do is I'll say access modifier as public for the time being. And here I'm going to define, I'll say std : string name. I'm defining a name variable of type string and I'm saying int temp id. So these are two variables I have defined. Now what I'm going to do is I'm going to create a method also. So I'll say void display open close braces here, and inside this I'll say cout of I'll say name and I'll say endl, and then I will just copy and paste this and I will put employee ID here. I'll copy and paste this as well. I'll put employee ID here. Now basically what we have done so far is that conceptually we have just created a blueprint or a template or a class. So starting from here to here, this is my class that has got created. So this is my class. Now let us go ahead and create an object of this particular class. So for that, I have to create an instance of this particular employee. I'll say employee E1. Now this particular statement which you see here, as I have said, this one, it is object of the class. Now when you want to access the members of this particular object, you'll say E1 dot name. Let's say you can say is equals to CPP, and then after that you can say E1 dot employee ID, EMPID, let's say equals to 1000. So as I had told you earlier in the slide that you can access the member name and employee ID using object and the dot operator. Now if you want to call the method, so you will simply say E1 dot display, and this is going to go ahead and call the display method of this particular class employee here. So let us try to run the program and see the output. So I will go to build, I will go to run, and I will say build and execute, and it will display me the value of name as CPP and the employee ID which I have set as 100. So basically this is how we create a class, which is this particular class, which is a template, and this is an object or an instance of that particular class. So coming back to our slides, we have seen how to create a class and how to create an object. So what is a constructor? Let us look at some of the important points to understand constructor. So basically, what is a constructor and why do we use constructors? Now constructor, it is a special method or a function of a class. Now why it is special? It is special because it has the same name as the name of the class, which we will see in some time with an example. Then it is called during object creation. So for example, if you have a class and when you create instance or an object of that class, a constructor gets called. Now it can be used for initialization. So if a class has variables, attributes, all those can be initialized with the help of a constructor. Now, as I've already mentioned, it has same name as the name of the class. Then it does not have any return type, not even void. We shall see that a constructor, it does not have any return type, and even the return type cannot be void itself. And also a constructor can be overloaded. So like a function which can be overloaded, we will see that constructor can also be overloaded. So let us understand the concept of constructors in more details with the help of this example in front of you. So we will look at object initialization in CPP, and we are going to look at stack implementation. We all know what is a stack. Stack is last in, first out. Now before we can use stack implementation, we need to set the top variable in stack. So let's say we have a top variable here. You might want to initialize top to an initial value. So let's say top equal to 0. Now this can be achieved by using a setter method in a class, which can be used to initialize the value of top to 0. But a better way would be to initialize the top variable with the help of a constructor. Why it is a better way? Because a constructor will get called automatically, whereas if you're using a setter method, you have to explicitly call that method. Now in C++, constructors are called when an object or an instance of a class is created. I have already mentioned this. And constructors are called implicitly. Implicitly means automatically they are called, and therefore there is no need to explicitly call the constructor method. And you can therefore use constructor method to initialize the top variable in this stack class. Now if you will look at this example in front of you here, I have a class which is a stack class, as you can see. Now it has a constructor, and as I have already mentioned that a constructor has same name as the name of the class. Now as you can see in this example, I have initialized the top of stack variable TOS with a value 0 in constructor. I might as well do the same thing in a setter method. As you can see, I have created a setter method here. So if you are using constructor, it will get called implicitly, whereas if it is a setter method, you have to explicitly call that method. So therefore it is always advisable and better to go for a constructor to initialize the variable top of stack. So now we'll try it out with an example. So I will bring up my CodeLight editor and begin with a coding example. So let us do some coding now. I'll create a class stack, open bracket, close bracket, and a semicolon here. Now I will create a int stack. This is an array of type integer of size 10, and I'll create a variable int TOS, which is top of the stack. Now I'll declare a public access modifier I'll say public colon. Now I'll define some methods here. So to begin with, I'm going to say void display ID, and inside this, I'm going to display the value of top of stack. So I'll say cout top of stack, and I'll say endl and a semicolon here. Now what I'm also going to do is, let me create a main method outside the class. So I'll say int main open bracket close bracket, and here what I'm going to do is I'm going to create an object of this particular class stack, and I'll call the object as S1. So now what I'm going to do is, let's run this program and see that everything is fine so far. So I will go to build, I will say run, or you can use shortcut as Control F5 and click on this, choose the option build and execute, and the code has built and executed successfully without any problem. So I'll hit enter to continue further. Now what I'm going to do is, I'm going to call the method display ID. So for that I'll say s1 dot display ID, and if I now again run this program, I'll do it with Control F5. I'll say build and execute. You will see an output of top of stack at 16. This is any garbage or a dummy value. Now this is because we have not assigned any value to the variable top of stack. Now we are going to assign a value with the help of a constructor. So let me go ahead and create a constructor now. We have already discussed earlier that a constructor is a method which has same name as the name of the class. So I will copy this. You can even type it, but I'm copying it here. So I will say stack open close bracket. Now this is a constructor as it has same name as the name of the class. So let me put a cout statement here. I'll say cout. I'll say I am constructor, and I will end it with endl. Let me capitalize the C here. Now for the time being, I'm going to comment this line. I don't need this for now. We'll uncomment it in some time. So as we have discussed earlier that a constructor gets called when an object is getting created. So whenever this particular line 23 is executed or an object S1 of the class stack is created, it will call constructor automatically, and we will see the output as I am constructor. So let us learn this program and look at the output. I'll say Control F5. I'll say build and execute, and you can see that output is I am constructor, which is coming from line number 17 where I have my mouse. Now you should be aware that I have not explicitly called constructor. Here I have just created an object, and that object creation invokes the constructor, which is at line number 16 here. Now the difference between the earlier method, which is display ID, and the constructor is that when you have a constructor, in this case a constructor without any parameter or argument, it will get automatically or implicitly called. Whereas if you have to call the display ID method, you have to explicitly call that method. So then what is the use of constructor? As we had already discussed earlier, that you can use constructor to initialize the variables. In this case, let's say you had to initialize the value of top of stack to 0. So now what I am going to do is, inside this constructor, I'll say TOS equal to 0, for example. Now, when this object is created, it will execute this constructor code, and the value of top of stack for S1 is going to be 0 now. Now, if I try to execute this line of code, which is at line number 25, you will see that the value of S1 is going to be 0 since we have already initialized it. So let me run this program. So you will see that it is calling I am constructor from the line number 18 here. And after that, when we are calling the method display ID at line number 25, the control is transferred to line number 12, and it displays the value of top of stack. So this is how the constructors work in C++. Now let us look at destructor. So as mentioned earlier, destructor is also having the same name as the name of the class. So I'll just copy and put it here, but it is preceded by a tilde sign. So I'll put a tilde sign here, and I'll close this curly braces. Now what I'm going to do is I'm going to display a message inside this, and I'll simply say cout. I'll just copy this in the interest of saving time. So I will copy this, and I will just name it as destructor. Now let's run this program once again. Now if I run this program, you will see that the destructor gets called automatically. So let me first run it and show it to you. So I'll say Control F5. I'll run this, and here you will see that I am destructor is getting called. So first the construction happened because of line number 28. Then because of line number s1.displayId, which is at line number 29, it displays the value of id as 0. And then the destructor method is getting called. Why? Because when the scope of variable s1 finishes, which is starting from line number 27 till line number 30, when the scope of this variable is coming to an end, or rather it is getting out of scope, then it is removed or destroyed from the memory, and therefore at that point of time the destructor gets called automatically. So before the main method completes, the CPP will internally call a destructor method at line number 21 and remove the object S1 from the memory. So to summarize all this discussion, constructor is a method which is called when you create an object of a class, and destructor is a method which is called when the object is getting removed from the memory. That's all in this discussion. So that was regarding the constructors. Now let us look at what is a destructor. So basically we are going to look at what is a destructor and why do we use destructors. So it is a special method or a function of a class. Again, it is special because it has a name which is same as the name of the class. But in the case of destructor, it has a name, and this name which is same as the name of the class is preceded by a tilde sign. Now it is invoked automatically when object is destroyed. So when an object is being removed from the memory of CPP, this particular destructor method is called automatically. Again, you don't have to explicitly call it. Now it has no return type and does not take any parameter. So a destructor cannot return any value, neither void, plus you cannot pass any parameters to a destructor. Now only one destructor is allowed per class, and a destructor cannot be overloaded. So you can have only one and only one destructor, and like in the case of constructors, overloading is allowed. It is not at all allowed in the case of destructors. There can only be one single destructor in a particular class, and it is used to perform cleanup operation. Cleanup operation meaning that if you have allocated some memory in the constructor, you might use destructor to clean up that memory. So let us understand again with the help of our stack implementation. Now destructors, I have already mentioned, a special method having the same name as that of a class, but it is preceded by a tilde. Now when an object is being removed from the memory, if it is being destroyed, its destructor is automatically called. Now a destructor is needed to do cleanup operations like deallocate memory. In this particular case, if you have allocated memory for a stack, you might want to deallocate the memory for that stack. Or in another case, for example, if you have opened some database connection, you might use destructors to close those database connections to free up the memory. Also, like constructors, destructor do not have any return value, not even void. So as I have already explained that a destructor has the same method name as you can see here, like the class, but it is preceded by a tilde sign. So if you will see, this is a destructor here, it is preceded by a tilde sign. And destructor is called automatically to free up the memory, and this is what we have already discussed earlier. So this is my VM. Now let us do some coding to understand the concept of default constructors. So first of all, I'll create a main method, and here I will simply say return 0. This method is not doing anything. I'm just getting started. Now let us go ahead and create a class stack. So I'll say class stack, open bracket, close bracket, and I'll end this class with a semicolon. Now inside this, I will say int stack. I'm creating a stack of type integer. Basically this stack is an integer array of size 10. Now these two are different. As you can see, this is uppercase, this is lowercase. You can give any other name if you would like to. STCK also is fine. So you can choose any name for this particular variable, whatever you want. And then I'll also create one more variable which is int TOS. This is top of the stack, TOS. So after this, I'll create a public access modifier here, or I will specify public access modifier, and I'll create one method and I'll call it display ID. I'll say void display ID. Void is the return type of the method. In this case, since I'm not returning anything, so I will specify the return type as void. And inside this, I'm going to display the value of TOS, which is COUT-TOS, and then I'll say ENDL. So this is my method created, which is displaying the value of top of stack. Now what I'm going to do is I'm going to create an instance or an object of stack. So I'll copy this, I'll paste it here, and I'll say S1. So basically this particular line will create an instance S1 of stack class. Now in order to call this method, what I have to do is I have to say S1 dot display ID, end it with a semicolon. Now let us just run this program before we get started with the concept of constructors. So I'll say build, I will say run, and I'll click on build and execute, and you can see the value of toss as 16 here. Now 16 is a garbage value which has been assigned to top of stack since we have not assigned any value. I'll hit enter to continue. Now what we are going to do is we are going to create a constructor. So as we have already mentioned in the earlier discussion, constructor is a special method which has same name as the name of the class. So I'll copy this and I'm going to paste it here, then open close bracket. Now here I am going to say cout. I'll say I am constructor and I will say and L and a semicolon. Now let us try to run this program. But before I do that, I will comment this line here, which is calling the display method. So I'll comment it. So after commenting the method, which is display ID, let us run this program and you will see the output as I am constructor here. Now let's try to understand what has happened. If you will see that in my program, when I created an object at line number 24 here, this in turn calls a constructor here. So basically execution of this line here, which is line number 24, it calls this particular constructor here, which I have highlighted for you. Now you will observe carefully that it displays an output I am constructor from this cout. Now one important point to note here is that I have not explicitly called the constructor, but constructor is called automatically when the object is created. So this is a default constructor, a constructor which does not take any argument, and it gets called when the object of that particular class is created. So therefore we see this output as I am constructor. So let me press enter and continue. Now what was happening when there was no constructor here or default constructor? Let me remove this and let me run the program once again. So I'll go to build, I'll say run, and this time you will not see any output. So basically what happens in CPP is that when there is no default constructor created in class, so in this case now I don't have any default constructor created, C++ will implicitly create one constructor for you, which is a default constructor, but it does not do anything or it does not perform any operation. So when you run this program, internally C++ has created a default constructor similar to this, except that there is no statement inside that particular constructor. So this is called a concept wherein it is implicitly, or the default constructor is implicitly created for you by C++. So let me continue with our discussion on constructors. So basically then what is the purpose of a constructor? So a constructor can be used to initialize the value of a variable. In this case, what I'm going to do is I'll assign top of stack equal to maybe 0 if that is what you want to do. You can assign any other value as well, but stack should be initialized for a stack. TOS or top of stack should be initialized to 0 or -1 depending upon your implementation. Now since I have assigned value of top of stack as 0, I'm going to call the method again, which is display ID. Let me uncomment this. So what happens when I execute this program, the flow is going to be something like this. So let me explain that with a drawing. So this particular execution will call the constructor here and it will display this value, and it will also initialize the value of top of stack as 0. And after that, when this particular line is executed, this will call display method or the display ID, and it will display the value of top of stack, which is equal to 0 in this particular case. So let me go and run this program and see the output. So I will say build, I will say run, and I'll say build and execute. Now as you can see here clearly that I have output first as I am constructor and top of value is initialized to 0. And after that, when we do a call to the method display ID, it will display the value as you see here is 0. So let me press enter and continue. So that is how the constructors work in C++. Now let us understand what is a destructor. So as I had explained earlier, destructor is also kind of a special method. So I will copy this and I'll put it here, open bracket, close bracket, and it is preceded with a tilde sign. Now inside this, I will say, in the interest of saving time, I am going to copy this and put it here. And I will replace constructor with a destructor here. So I'll say the destructor. Now destructor, as you can see, has the same name as the name of the class, except that it is preceded by a tilde here. Now when is a destructor called? Destructor is called when the scope of this variable comes to an end. So this particular variable S1 which has been created has a scope which starts from this particular line, which is 27, or opening of this bracket, to the closing of this bracket. Now if I run this program, you will see that this particular destructor also gets called automatically. And when is that getting called? Just before the main method comes to end. And it is because the scope of S1 is getting terminated. So let's run this program and see the output. So I will go to build, run it, and say build and execute. Now you can see that IAM destructor is getting called here. That is because of this particular destructor that we have created, as I have already explained. So that is how the destructors work in C++. What is object-oriented programming? Now, as you can see from this slide in front of you, object-oriented programming is a programming paradigm which aims at tying the data to the function which operates on it. It prevents the data from being accessed from or by other functions and ensures data security. So what it basically means is that if you have a class in place, so let's say I have this class here, this is one class, and I have one more class with me. Let's say this is another class. Now with these two classes, what I can do is I can create some data here, and I can create some data in this class as well. Now, as you can see, it prevents the data from being accessed by other functions and ensures data security. So the data which is in this class, let's say class A, and this is class B, for example, the data within this can only be accessed by member function of A, and this can be accessed by member function of B, provided the data has been defined as or declared as private. So coming back, some of the characteristics of OOPS are as follows. It divides the program into multiple smaller units known as objects. So we have covered classes and objects in our different modules in details. So in this particular discussion, when we create a class, from class we can create objects. So that way it helps us to divide program into smaller units which are actually objects. Then each object consists of data and its own set of functions to access the data. So if you will look at this diagram which is in front of you, this is an object of a given class. So let's say I had a class employee. For example, this is my class employee. And then I have object A of employee and object B of employee. Now for this particular object, there will be some data within that. Let's say name of that employee and name of another employee. Now this data member can be accessed only by the member function, which is this one, for this particular object. Same goes with the other object. So each object consists of data and its own set of functions to access that data. Now the data of an object is hidden and can only be accessed by the function belonging to that object. This I have already explained. Then objects can communicate among each other through functions. So let's say if I have an object 1, or rather object A and object B, if I have to communicate between these two objects, what I need to do is I create object of that particular class maybe, or if it is a same class or another class, whatever it is, I can create an object of a class and then call the method in that class using that particular object. So this is how the communication happens. So this is representation of the organization of data and functions in an object and communication between objects in the case of OOPS. So let's go to the next slide now. So what are the features of object-oriented programming? We have following important features: that it has object, it has class, there is a concept of encapsulation, there is a concept of inheritance, polymorphism, and abstraction involved. So let us look at all of this one by one in details. So I will go to my next slide. Now what is a class and what is an object? A class is user-defined data type which has data member and member functions, but no memory is allocated for it. Also, it can be accessed by creating an instance of a given class known as object. So we know the distinction between a class and an object. A class is blueprint or a skeleton of an object. So these details, they have been covered separately in more details in a module called classes and objects. So for the time being, please understand that class is a blueprint and object is an instance of that class or a blueprint. Now object is an instance of a class. It is a variable of class type. It consists of data members and member functions defined by the class. Objects use the member functions to access and modify the data members. So for example, so let's say this is a class, let's say employee, EMP I'll call it for now, open bracket, close bracket with curly braces. So I can have attributes here and functions here. So how do I create object of this? I'll simply say EMP E1 or E2 or whatever name you want to give. And after that, you can access the member of that particular class, which is attribute or a function, by saying E1 dot attribute name or function name. So here I have taken an example of a class maybe, which could be a fruit type or it could be a mobile. So we can represent these entities or objects with the help of a class. What is meant by that is, let's say I have a class fruit and I have a class mobile. Now I can say fruit and I can give it name as, so this is the class name, and then I can say apple. So I'm creating an object of that fruit class and it is an apple. Now in order to make it apple, I can of course assign attribute values to this particular object apple as per apple. Same goes with the other types with this orange as you see here. Same applies, or same concept applies here, that if I have a class mobile, I can create an object and it could be maybe iPhone or an Android. So this is how we make use of classes and objects in C++ programming. So then next is encapsulation. What is encapsulation? So encapsulation, it is the process of binding the data to a function forming a single unit known as class. And this concept is known as encapsulation. So basically the idea here is this, that you can think of it as a capsule as you see in front of you. And then you can define members which are generally private and functions which are public. And with the help of this member function, you can access these data members. So this is a concept of encapsulation. So basically encapsulation is combination of en plus capsule. So you encapsule the data and the functions together within a class. This concept is known as encapsulation. Now encapsulation can be achieved by making the data members private and the member function as public to enable them to access the data members. Now it prevents the data member of a class from being accessed from anywhere outside the class. So let's say you have another function here, or rather another class. So they cannot directly access the data members, or rather this class cannot directly access the data members. If they have to access, they have to go via the member function, and then only the access is allowed. So this way we achieve data protection, or this is a concept of encapsulation. Now it enables the data member to be accessed only by the member function of that particular class. This I have already explained to you. Now the next important concept is abstraction. So let's look at what is abstraction. Abstraction is the process of representing only the relevant information about the data while hiding the background implementation details is known as abstraction. So basically, what does it mean? Let's understand it in a little bit more details. So we can achieve abstraction using class as well as using header files in C++. Now what is in abstraction using class? The visibility of the components of class, that is data member and member function, can be decided by the class by using or specifying access modifier. Now therefore abstraction can be implemented by hiding implementation details, which could be data, by making them private, and the information to be displayed can be made public. So maybe we can use the functions to access the private member of the class in C++. This is a concept of abstraction which is achieved with the help of a given class. Now we can also make use of this concept or implement this concept using header files. We have used header files in good number of our programming. So let's understand that. So abstraction using header files. Header files are used to import predefined functions into a program. For example, in the header file stdio.h, there are functions cin and cout. So basically we use these two functions to read and write values in the program, or rather read the value and write the value. The utility of this function is to know to all, or rather we all know the utility of these functions is known, right? But do we really know the process implementation of these functions? No, we do not know, because the details are hidden from the user. This is how abstraction is implemented using header files. So basically the point is that by simply importing the header file, we get access to those functions and we just go ahead and use those functions instead of worrying about the underlying details. This is a concept of abstraction using header files in C++. What is inheritance? Inheritance is a concept where a subclass gets all the feature of an existing base class, which improves reusability of existing code. So what it means is that, let's say you had a class, let's say this is a car class, CAR, and you want to create a specific kind of a car. Maybe it could be a BMW car, for example, or Maruti car, right? Now, if there is already an existing functionality in car, which can be used by BMW or Maruti, we should inherit the car class, or BMW should inherit this and Maruti should also inherit it. That is what it is trying to say. This is a concept where a subclass gets all the feature of existing base class. So if something is already there, let's get all the features. Now inheritance provides a method for creating new classes from existing. So these are the new classes. This is an existing class. Creating, for example, you create a scientific calculator from existing simple calculator. So in case you had a simple calculator which was performing basic operations of adding numbers, multiplying numbers, now you want to create a scientific calculator which can calculate square root and other complex functions as well. So you should not rewrite the entire scientific calculator class from scratch. You can create a scientific calculator class and it can extend the existing basic calculator, and then you can continue to add the new functionality. So these new classes contain the data and behavior of existing class. So when we do inheritance, whatever is there will become part of the subclasses as well, the members, which is the attributes and methods. And also it allows us to reuse or inherit data and behavior that already exist, as I just said. Now the superclass is known as base class and subclass is also known as derived class. So you get to use what is already there here, plus additionally, you can add more functions and attributes here. So the idea is that you take what is existing, use it, plus add more features. This is a concept of inheritance. And syntactically, this is how it looks. We will try it out with an example in some time. So you can say class, name of the class. Here you specify colon, then you specify access type and the name of the superclass. So this is a subclass and this is a superclass with respect to inheritance. So let's take a very simple example to understand what is inheritance. Similarly, we may have different types of shapes that we can draw, such as line, oval, circle, square, and so forth. Depending on our application, we can identify common attributes that all shapes have, for example, color. So let's say I have this hierarchy in place where I have a shape, and there can be different kinds of shapes here. So I can define a method color, and this color is a method which gives colors to different shapes, that is the subclass of the shapes class. Now, since this method could be commonly used by all these subclasses, smiley, cone, and star, so a good idea is to basically inherit the existing shape class. Smiley is also a shape, cone is also a shape, star is also a shape. So we can reuse what is existing and then additionally add more feature in this individual subclasses. So syntactically, this is how it will look. There is a class shape which is existing. Then we say class smiley, colon, public, and shapes. Same way we do it for the other subclasses. So this is how we basically make use of inheritance. Syntactically, don't worry, we are going to try out all of this with some examples in some time. Now let us talk about different types of inheritance. So we have single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, and hybrid inheritance. So these are different options or different types of inheritance that are available in C++ programming. Depending upon your need and your requirement, you can choose to use any one of them which suits your, or rather which solves your problem statement. So feel free to use which one solves your problem statement. So let's move on. So what is single inheritance? So single inheritance, as you can see, the process in which a derived class is inherited from only one base class is known as single inheritance. So you have only one superclass and one subclass. Simple syntax is you create a class, you create a subclass, and this subclass extends the superclass. So therefore, since this is a public member, this will get inherited and will be available in the car class. Now, as far as accessibility of the members in the superclass is concerned, we have already discussed this concept in details in access modifiers in other modules. But as of now, please understand that in single inheritance, there is a single subclass and a single superclass with respect to the concept of single inheritance. So now let us try to understand the concept of inheritance with the help of some coding examples. So for that, I will head over to my lab VM where we'll try out some of these examples. I already have a class vehicle and I have a public constructor and a method here, as you can see. Now this class starts here, this bracket, and ends here with a semicolon. Similarly, I have one more class with a constructor and a method display car, and this is display vehicle. Now, in order to do inheritance or in order to implement inheritance, what I have to do is, as you can see here, syntactically, I'll say car colon public and then the superclass name. So let's do that. So what I'll do is I'll say car colon, I'll specify access modifier public and then followed by the name of the superclass, which is vehicle here. So I'll copy and paste it here. Now what I'm going to do is, first of all, I'm going to create an instance of the superclass, which is vehicle. So I'll copy this. I'll go to my main method here and I'll say vehicle v1. With this object, I can call the method this method. So let's do that first. Now I'll say v1 dot method name and let me run this program and see the output. And as we are aware that this particular object v1, once it is created, it will call its constructor. This is the default constructor. So first we'll get this as an output. This is vehicle. And finally, when the method is called, we'll get this as an output. So let me run this program. I'll say build, I'll say run, and I'll say build and execute. So let us go and see the output here. So it is saying this is vehicle, which is coming from constructor, and this is display vehicle, which is coming from the method call. So this I have to close. This is my earlier executed output. So from this program, we got output as first this one from constructor and then this one from the method. Now what I'm going to do is, let me comment this. Now I'll create instance of subclass, which is car. So let's go ahead and do that. I will create object of this C1. You can give it any name and then I'll say C1 dot. So you will see now it gives me an option to call both the methods car, and let's also call the other one as well. I'll say display. Let me delete this and I'll say vehicle. Now, because of inheritance, what has happened is the member which is in the superclass here, the vehicle, it gets inherited in this class publicly because we have used public access modifier, and therefore with the instance of car class, I can also call this particular method display vehicle. Now, one important thing to note here is that when an object for the class car is created, so it in turn extends vehicle, right? So the hierarchy is like this. This is my vehicle and this is my car. Let me represent inheritance by this way. So car is extending vehicle. Now, when I'm creating an instance of a class car and this car is extending a vehicle, it is necessary that before I can create an instance of car, the vehicle instance should be existing. Meaning that if car has to exist, vehicle should also exist because car is extending the class vehicle. So when you create an object of car class, what will happen? It will come to the constructor of the car here and it will see that this car extends another vehicle. So first of all, it will go to the constructor of the superclass, which is vehicle in this case, and it will display first this is vehicle, then it will come back and display this is car. So the order in which the constructor will get called is the one from the superclass is called first and the one from the subclass is called later. So as an output, first we'll see this one, then this we'll see output 2. And after that, depending upon the method call, then you are calling display car and then display vehicle. So then it will call the display car output and display vehicle output. Okay, let's try to run this program. I'll say build and run and let's see the output. So I'll go here in the output window and see, you will see this is vehicle, this is car. So this vehicle is coming from superclass constructor, then subclass constructor. Then I'm displaying car here, as you can see at line number 45 here, this one, and then display vehicle. So this is the order in which the execution will happen. So basically first the superclass constructor, this is superclass constructor, subclass constructor, then the method call, which we have done explicitly at line number 45 and 46 in this particular example. So basically this is how the concept of inheritance works, wherein a class can extend another class with an access modifier specified here. And this concept is single inheritance concept. Then next is multiple inheritance. So what happens in multiple inheritance? The process of deriving a new class which inherits the attribute from two or more classes is known as multiple inheritance. Now here you have a vehicle. A vehicle could be inheriting a car and a bus and a train, maybe, for example. This is a hypothetical scenario or an example. So maybe vehicle will get the attributes or methods of car and also bus and also train. This concept is known as multiple inheritance. And syntactically, you say class. So you already have the three classes, superclasses. Then you say class vehicle colon. You specify the access modifier and the name of the superclass, comma, again access modifier, and then the superclass bus, and then again access modifier and the superclass train. Now, what is the significance of this access modifier? This has already been covered in a different module, access modifier. Please feel free to refer to that module. But for now, we are talking about a single class inheriting methods and attributes from multiple classes, which is a concept of multiple inheritance in C++. So now let us look at coding example for multiple inheritance. So here I have one class with a constructor and another class with a constructor, right? Now what I have to do is syntactically, as you can see in this slide here, I'll say colon public, the other car and the other bus class. So let's go back here. I'll say colon public vehicle, let's say, and then I'll say comma public, again access modifier and four-wheeler. So basically what we have done is this particular class car, as you can see in this case, extending vehicle as well as four-wheeler. So this is a concept of multiple inheritance. Now let's come back here. Now let's try to put some code in the main here, and we will put some code here in the main. Now what I'm doing here is I'm creating an object of subclass which is car. And we have seen in the previous example that because car is extending vehicle, so first of all, the constructor of vehicle will get called and it will display this is vehicle, and it will then also display the constructor from four-wheeler. So if I run this program, we should see output from the superclass constructors. So let's do one more thing. I'll create one more constructor here and I'll call it car, public access modifier. I'll say car, and here I'll say cout, this is car, this is car, car, and I'll say endl. Now let us try to run this program. So first of all, we'll get the call to the constructor from the superclasses and the subclasses. So let's go to build, let's go to run and say build and execute, and let us see the output. I'll go to the output window and you will see that first we say, see the output as this is vehicle, then this is four-wheeler vehicle, and this is car. And as I have already explained, because car is extending vehicle, so it will give output from constructor of the vehicle class, then from four-wheeler, and then the car class constructor is called. So this is how the concept of multiple inheritance works in C++. Then next is hierarchical inheritance. The process of deriving more than one class from a base class is known as hierarchical inheritance. So we have more than one class, as you can see, which is extending or inheriting from a vehicle class. Syntactically, you create a class, and then what you can do, there is a class which is extending vehicle, car is extending vehicle, bus is also extending vehicle. So this is a concept of hierarchical inheritance in C++. Let's look at this with an example. So let us look at coding example for hierarchical inheritance. So I have a vehicle class, then I have a car and a bus class. So here I'll say colon public vehicle public vehicle VHI. And then here also I'll say colon public and then vehicle. Now, if you will see, this is what we had done in hierarchical, that we have different classes which is extending the same superclass. Same thing I have done here, class car and bus extending the same superclass vehicle. Now, if I go ahead and create an instance of car, so let's say car I'll create. So car, I'll say C1, maybe any name you can give, and then I'll say bus B1. So what this will do is when I create an object of car C1, it will come here, which in turn will call the superclass constructor. So you'll get this as an output once, and then finally, because of the second bus B1 object creation, again you will get the output as vehicle. So let us create one more constructor here. First, I'll specify the access modifier public colon, and let's say I will call it constructor here. I'll say cout I am car endl, and then let me also, I'll just copy and paste all of this, and I'll just change the name in the subclass here in the bus. So let me just copy this here, put it here, right, and I'll put this here as well. So now we know that when I'm creating C1, it will come to this constructor, display this, but before it displays this, it sees that it also has a superclass vehicle. So I'll copy this and correct this. This is vehicle here. So it will go to the superclass, first display I am vehicle, and then it will display I am car. And then from the next statement, bus V1, it will come here. It sees that it has a superclass. It will go to the superclass constructor and display the value from superclass constructor, and then finally display the value from this constructor, right? So let us see the output of this program. So as you can see that first of all, I get an output. This is vehicle and then this is car. And then finally, this is again vehicle and bus. So this is coming from first object and this is coming from second object. So this is how the concept of hierarchical inheritance works in the case of C++. The next is multi-level inheritance. As the name suggests, there are different levels. If I call this as level 1, 2, 3, then 3 extends 2, which in turn extends 1. So the process of deriving a class from another derived class is known as multiple inheritance. Syntactically, car is extending four-wheeler, so this one, and four-wheeler is extending vehicle. So what will happen, the attribute which is here, let's say there was an attribute, public attribute A, variable A, which came here. And if you have publicly extended the class, then as you can see, I have used public keyword here, then A will be available from vehicle to four-wheeler. And again, if we are doing public inheritance, this again will be available here. So this way we achieve multi-level inheritance in C++, meaning that depth or the level of inheritance is when one class is extending another class, which in turn is also extending another class. So this is a concept of multi-level inheritance in C++. So let us try it out with an example. So here I have three classes, as you can see. I have a vehicle, four-wheeler, and a car. So let us begin our inheritance. In this case, we'll talk about multi-level inheritance. So first I will go to four-wheeler and say colon public vehicle, and then here I'll say class car colon public, and then I'll say four-wheeler. Now if you will see, what I have done is hierarchy has become something like this. So I have a superclass, subclass, and another subclass here, right? So if this is my vehicle, this is my four-wheeler, and this is my car. Let me erase this. So coming back, so what I'm doing is if I create an object of this class, which extends this, which in turn extends this. So this will first call this constructor, this will call this constructor, and this is how it works like we have seen earlier. So let me go and create an object of car. It will come here, and then it will come here, this constructor, and then it will go here. So first of all, it will display the value from vehicle, which is this is vehicle, then from the four-wheeler, and then finally from the car. So let's try to run this program and see the output. I'll go to P1 here, and this is vehicle from supermost class, then object with four wheels are vehicle, car with four wheels. So this is how the output is generated. Now also, whatever you define in the topmost class, so let's say I define a method here, void method cout. I'll display here, this is method from CL, and then here I'll say endl. Now what happens is, when you have the supermost class A, B, and C, and inheritance is involved, so what will happen? This will inherit, or rather the methods and attributes from A will get inherited in B, and from B it will get inherited in C, since we have made use of public access modifier. To know more about this access modifier, check out the module access modifier. So if I've defined a function here, method, and I'm publicly inheriting it in this B class, which in turn is being inherited by C class, then I can create instance of CC and then call that particular method, which is this particular method. So let's try to call this method and see the output. So what I have done here is I have created an object of car class, which is the one at the bottom in the hierarchy. And then I call this method, and this method is basically, if you will remember, that it is in the topmost class in the hierarchy, right? So with the object of the subclass, I'm calling the method in the topmost class. So let me run this program. I'll say build, I'll say run, and then I'll say build and execute. And let's go to this window and see the output. So you can see that I'm able to display this is method from vehicle. So this is how the method from the superclass will get inherited in the subclass down in the hierarchy. So this is how the concept of multi-level inheritance works in C++. Then the next one is hybrid inheritance. As you can see, the combination of more than one type of inheritance is known as hybrid inheritance. So you have basically a car and a bus which are actually vehicles. So car is extending a vehicle, bus is also extending a vehicle. Car is extending a vehicle here. As you can see, car extends vehicle and bus is also extending a vehicle. Now you have a fare class which in turn is extending car and a bus. So basically this kind of inheritance which is available in C++ is known as hybrid inheritance. Now as I have already told you, you might be curious to know that which one to use when. So as such there is no specific rule or guideline, but depending upon the problem statement that you are trying to solve, you should use either one of them. So for example, let's say if you have this particular inheritance, let's say multi-level. So this is a nice example. So you can have a vehicle at the top in the hierarchy. Under that you can have a four-wheeler. Under four-wheeler you can have a car. Under car you can go to one more depth, which is, let's say, Maruti, for example. Similarly, under vehicle you can have two-wheeler also, two-wheeler. Here you can have bike. Underneath you can have different brands of the bike. So this is basically you are trying to achieve multi-level inheritance. So this way, depending upon the problem statement that you are trying to solve in your program at any given point of time, you have to decide to choose a most suitable inheritance concept to solve your problem. So let us look at an example to understand that. So I'll go to my VM here. I have a class here, vehicle. This and this is extending vehicles. So diagrammatically, if you want to draw it, this is vehicle. Then I have car and bus, which is extending vehicle. And then finally a fare class, which is extending this car and bus. And then finally you can create instance of fare or whatever class, and the conceptual working of the different calls to constructors and method remain same as I have already explained. So these are different ways how you can use inheritance in C++. Now, what are some of the advantages of inheritance? So basically, the main advantage of inheritance is that we reuse the existing code that might have been created by other developer. So as I had told earlier, you have something in place. So let's say you are trying to construct or build a new car. So you don't want to build a car from the scratch. Let's say there was already an existing car features or functionalities available. Then you are creating a new car, and let's call it, for example, Zoom car. I mean, Zoom, we already know, is available as a rental car. So if you are trying to create Zoom car, what you can do is you can take the existing car, extend that, and maybe you can add more additional features, functionalities. So basically we reuse what is existing. That is the emphasis or the main concept of inheritance. As the name suggests, inheritance means you inherit what is existing or what is already there. Like you inherit features, attributes from your parents. Now the child class can inherit superclass to reuse what is existing and add newer functionalities to the base class to enhance, upgrade the existing functionalities. So as I said that when you inherit, you get what is available in car. Of course, what you get will depend upon the access modifier in this class. This concept of access modifier I have covered in a separate module of access modifiers. Please refer to that. But what is there in car you get in Zoom, and plus additionally you can add new features that you want to enhance a car class and then build a Zoom car of your choice. For example, BMW might extend a car class and enhance it to its engine power in subclass to give a better performance. So as I have already told you, we are basically trying to achieve reusability and then extend the functionality by adding more features and functionalities in the subclass. So these are the major advantages of inheritance in C++. Then we have next concept which is very important is polymorphism. Now what is polymorphism? Polymorphism means the ability to have multiple forms basically. Poly means many, morphos means kind. So it is a concept of a feature exhibiting multiple forms, you can call. Now in OOPS, it is the ability of an operation to behave differently in different instances. So what does it mean? It means that we have two concepts, compile time and runtime polymorphism. Now under this we have function overloading and operator overloading. So what is function overloading? It is a process of using functions having same name to perform different operations. So basically you can have a function sum, for example, in which you can pass two arguments, integer a and b, or you could pass three arguments a, b, c. Of course you have to specify the data type. So this is a concept of function overloading where you have same function name but different number of arguments or different types of argument. This is a concept of function overloading. Similarly, you have operator overloading. It is a process of making operator behave differently in different instances. So let's say you have plus operator. You can add maybe a 2 integer, int plus int you can do, or you can create your own object 1 plus object 2 and add them. In order to implement this addition, of course, you have to override this operator within the class of this particular object, but it can be achieved. So this is a concept of operator overloading in C++. Then we also have runtime polymorphism, which is known as dynamic binding. So in the case of virtual functions, how it is implemented, let's see, it is a function in the base class, which is overridden in the derived class and is used to specify the version of function to be called by the compiler. So to understand this, let's say I have a base class, which is a car, and I have another class, which is derived class, which is BMW, let's say, for example. Now this has a method start engine, for example, and maybe this has also a start engine. So basically what I'm trying to do is I'm trying to override an existing functionality which is already available in superclass in my subclass, and this is achieved using virtual function. So we are going to look at details of virtual function implementation in a separate module. But basically here the concept is that we have a function in base class which is overridden in the derived class, and we call a specific version of that particular function. So that is virtual functions. And then we also have pure virtual functions. What it is a virtual function for which function definition is not required. So there is a separate module, as I stated, virtual functions, where we are going to look at details of how this concept works in the case of C++.
What is overloading? Overloading is a process where we create 2 or more members of a class having same name but different number of parameters. We can overload by using methods, constructors, and indexed properties. There are basically 2 types of overloading, which are functional overloading and operator overloading. Now let us execute an example based on overloading. So this particular example is based on function overloading, and here we are having 2 methods on the same name, that are add and add. One method is having 2 parameters and the other one is having 3 parameters. Now let us execute this program and see how does it work. As you can see, both the functions have been executed successfully without any problem, and we have the results of the functions as well. Now let us move on to the next topic, which is overriding. When a derived class has a function with the same name as a function of the base class, then it is called as function overriding. Both functions must have the same number of parameters in both the classes. Now let us execute a program based on function overriding to understand the terminology in a better way. So this particular program is based on functional overriding. Here we have a function called desc in the base class. Similarly, we have another function in derived class with the same name called disp. So let us execute this program and see how does it work. You can see that the program has been successfully compiled and the output has been displayed here. So this is how the overriding works in C++. Now let us take a step further and find out the differences between function overloading and function overriding. First difference is that the scope is same in overloading, whereas in overriding the scope is completely different. Then the second difference, signatures must differ when you're overloading, but whereas signatures must remain same when you're overriding. The next difference is multiple overloading is possible, whereas multiple overriding is not possible. And the last difference between the both is overloading can occur without inheritance, while overriding will occur only because of inheritance. Now let us move on further and understand interface. The interface is a solution to implement the behavior and functionalities of the parent class into the child class from its parent class without the actual involvement of the members of the parent class. So this is the syntax for applying interface in C++, which is double underscore with interface, which is the keyword. Followed by that, we have to mention the interface name. And inside the block, you can have your own statements. Now let us execute a program based on interface to understand its terminology. So this particular example is based on interface. Now let us execute this and see how does it work. As you can see, the program has been successfully compiled and the output has been generated here. Now let us move on to the next concept, which is friend. A friend function of a class is outlined outside that particular class's scope. However, it is possible to access all the private and protected members of a class. Basically, this property is a bit insecure when it comes in the real time. However, let us see the syntax to use friend functions in C++ programming. Class is the keyword here, followed by that you have to provide the class name to which you have described your friend function, and inside the block you have to use the keyword friend, followed by that you have to place a data type and the function name inside which you have the arguments. Now let us execute a program based on friend function to understand its terminology in a much better way. So this particular example is based on friend function. Now let us try to execute it. You can see that the program has been successfully compiled and the result is displayed here.
Let's take up a quiz question. Which of the following statements about friend function in C++ is true? Options are given on the screen, and if you know the answer, please leave it in the comment section below.
What is a constructor? Let us look at some of the important points to understand constructor. So basically, what is a constructor and why do we use constructors? Now, constructor, it is a special method or a function of a class. Now, why it is special? It is special because it has the same name as the name of the class, which we will see in some time with an example. Then it is called during object creation. So, for example, if you have a class and when you create instance or an object of that class, a constructor gets called. Now, it can be used for initialization. So if a class has variables, attributes, all those can be initialized with the help of a constructor. Now, as I've already mentioned, it has same name as the name of the class. Then it does not have any return type, not even void. We shall see that a constructor, it does not have any return type, and even the return type cannot be void itself. And also a constructor can be overloaded. So like a function which can be overloaded, we will see that constructor can also be overloaded. So let us understand the concept of constructors in more details with the help of this example in front of you. So we will look at object initialization in CPP, and we are going to look at stack implementation. We all know what is a stack. Stack is last in, first out. Now, before we can use stack implementation, we need to set the top variable in stack. So let's say we have a top variable here. You might want to initialize top to an initial value. So let's say top equal to 0. Now this can be achieved by using a setter method in a class, which can be used to initialize the value of top to 0. But a better way would be to initialize the top variable with the help of a constructor. Why it is a better way? Because a constructor will get called automatically, whereas if you're using a setter method, you have to explicitly call that method. Now in C++, constructors are called when an object or an instance of a class is created. I have already mentioned this. And constructors are called implicitly. Implicitly means automatically they are called, and therefore there is no need to explicitly call the constructor method. And you can therefore use constructor method to initialize the top variable in this stack class. Now if you will look at this example in front of you here, I have a class which is a stack class, as you can see. Now it has a constructor, and as I have already mentioned that a constructor has same name as the name of the class. Now as you can see in this example, I have initialized the top of stack variable TOS with a value 0 in constructor. I might as well do the same thing in a setter method. As you can see, I have created a setter method here. So if you are using constructor, it will get called implicitly, whereas if it is a setter method, you have to explicitly call that method. So therefore it is always advisable and better to go for a constructor to initialize the variable top of stack. So now we'll try it out with an example. So I will bring up my CodeLight editor and begin with a coding example. So let us do some coding now. I'll create a class stack, open bracket, close bracket, and a semicolon here. Now I will create a int stack. This is an array of type integer of size 10, and I'll create a variable int TOS, which is top of the stack. Now I'll declare a public access modifier. I'll say public colon. Now I'll define some methods here. So to begin with, I'm going to say void display ID, and inside this I'm going to display the value of top of stack. So I'll say 𝐶𝐽𝑢t top of stack, and I'll say ENDL and a semicolon here. Now what I'm also going to do is, let me create a main method outside the class. So I'll say int main open bracket close bracket, and here what I'm going to do is I'm going to create an object of this particular class stack, and I'll call the object as S1. So now what I'm going to do is, let's run this program and see that everything is fine so far. So I will go to build, I will say run, or you can use shortcut as Control F5 and click on this, choose the option build and execute, and the code has built and executed successfully without any problem. So I'll hit enter to continue further. Now what I'm going to do is, I'm going to call the method display ID. So for that I'll say s1 dot display ID, and if I now again run this program, I'll do it with Control F5. I'll say build and execute. You will see an output of top of stack at 16. This is any garbage or a dummy value. Now this is because we have not assigned any value to the variable top of stack. Now we are going to assign a value with the help of a constructor. So let me go ahead and create a constructor now. We have already discussed earlier that a constructor is a method which has same name as the name of the class. So I will copy this. You can even type it, but I'm copying it here. So I will say stack open close bracket. Now this is a constructor as it has same name as the name of the class. So let me put a cout statement here. I'll say cout. I'll say I am constructor, and I will end it with ENDL. Let me capitalize the C here. Now for the time being, I'm going to comment this line. I don't need this for now. We'll uncomment it in some time. So as we have discussed earlier that a constructor gets called when an object is getting created. So whenever this particular line 23 is executed or an object S1 of the class stack is created, it will call constructor automatically, and we will see the output as I am constructor. So let us learn this program and look at the output. I'll say Control F5. I'll say build and execute, and you can see that output is I am constructor, which is coming from line number 17 where I have my mouse. Now you should be aware that I have not explicitly called constructor. Here I have just created an object, and that object creation invokes the constructor, which is at line number 16 here. Now the difference between the earlier method, which is display ID, and the constructor is that when you have a constructor, in this case a constructor without any parameter or argument, it will get automatically or implicitly called. Whereas if you have to call the display ID method, you have to explicitly call that method. So then what is the use of constructor? As we had already discussed earlier, that you can use constructor to initialize the variables. In this case, let's say you had to initialize the value of top of stack to 0. So now what I am going to do is, inside this constructor, I'll say TOS equal to 0, for example. Now when this object is created, it will execute this constructor code, and the value of top of stack for S1 is going to be 0 now. Now if I try to execute this line of code, which is at line number 25, you will see that the value of S1 is going to be 0 since we have already initialized it. So let me run this program. So you will see that it is calling I am constructor from the line number 18 here. And after that, when we are calling the method display ID at line number 25, the control is transferred to line number 12, and it displays the value of top of stack. So this is how the constructors work in C++. Now let us look at destructor. So as mentioned earlier, destructor is also having the same name as the name of the class. So I'll just copy and put it here, but it is preceded by a tilde sign. So I'll put a tilde sign here, and I'll close this curly braces. Now what I'm going to do is I'm going to display a message inside this, and I'll simply say cout. I'll just copy this in the interest of saving time. So I will copy this, and I will just name it as destructor. Now let's run this program once again. Now if I run this program, you will see that the destructor gets called automatically. So let me first run it and show it to you. So I'll say Control F5. I'll run this, and here you will see that I am destructor is getting called. So first the construction happened because of line number 28. Then because of line number S1 dot display ID, which is at line number 29, it displays the value of ID as 0. and then the destructor method is getting called. Why? Because when the scope of variable S1 finishes, which is starting from line number 27 till line number 30, when the scope of this variable is coming to an end, or rather it is getting out of scope, then it is removed or destroyed from the memory, and therefore at that point of time the destructor gets called automatically. So before the main method completes, the CPP will internally call a destructor method at line number 21 and remove the object S1 from the memory. So to summarize all this discussion, constructor is a method which is called when you create an object of a class, and destructor is a method which is called when the object is getting removed from the memory. That's all in this discussion. So that was regarding the constructors. Now let us look at what is a destructor. So basically we are going to look at what is a destructor and why do we use destructors. So it is a special method or a function of a class. Again, it is special because it has a name which is same as the name of the class. But in the case of destructor, it has a name, and this name which is same as the name of the class is preceded by a tilde sign. Now it is invoked automatically when object is destroyed. So when an object is being removed from the memory of CPP, this particular destructor method is called automatically. Again, you don't have to explicitly call it. Now it has no return type and does not take any parameter. So a destructor cannot return any value, neither void, plus you cannot pass any parameters to a destructor. Now only one destructor is allowed per class, and a destructor cannot be overloaded. So you can have only one and only one destructor, and like in the case of constructors, overloading is allowed. It is not at all allowed in the case of destructors. There can only be one single destructor in a particular class, and it is used to perform cleanup operation. Cleanup operation meaning that if you have allocated some memory in the constructor, you might use destructor to clean up that memory. So let us understand again with the help of our stack implementation. Now destructors, I have already mentioned, a special method having the same name as that of a class, but it is preceded by a tilde. Now when an object is being removed from the memory, if it is being destroyed, its destructor is automatically called. Now a destructor is needed to do cleanup operations like deallocate memory. In this particular case, if you have allocated memory for stack, you might want to deallocate the memory for that stack. Or in another case, for example, if you have opened some database connection, you might use destructors to close those database connections to free up the memory. Also, like constructors, destructor do not have any return value, not even void. So as I have already explained that a destructor has the same method name as you can see here, like the class, but it is preceded by a tilde sign. So if you will see, this is a destructor here, it is preceded by a tilde sign. And destructor is called automatically to free up the memory, and this is what we have already discussed earlier. So this is my VM. Now let us do some coding to understand the concept of default constructors. So first of all, I'll create a main method, and here I will simply say return 0. This method is not doing anything. I'm just getting started. Now let us go ahead and create a class stack. So I'll say class stack, open bracket, close bracket, and I'll end this class with a semicolon. Now inside this, I will say int stack. I'm creating a stack of type integer. Basically this stack is an integer array of size 10. Now these two are different. As you can see, this is uppercase, this is lowercase. You can give any other name if you would like to. STCK also is fine. So you can choose any name for this particular variable, whatever you want. And then I'll also create one more variable which is int TOS. This is top of the stack, TOS. So after this, I'll create a public access modifier here, or I will specify public access modifier, and I'll create one method and I'll call it display ID. I'll say void display ID. What is the return type of the method? In this case, since I'm not returning anything, so I will specify the return type as void. And inside this, I am going to display the value of TOS, which is COUT-TOS, and then I'll say ENDL. So this is my method created, which is displaying the value of top of stack. Now what I'm going to do is I'm going to create an instance or an object of stack. So I'll copy this, I'll paste it here, and I'll say S1. So basically this particular line will create an instance S1 of stack class. Now in order to call this method, what I have to do is I have to say S1 dot display ID, end it with a semicolon. Now let us just run this program before we get started with the concept of constructors. So I'll say build, I will say run, and I'll click on build and execute, and you can see the value of toss as 16 here. Now 16 is a garbage value which has been assigned to top of stack since we have not assigned any value. I'll hit enter to continue. Now what we are going to do is we are going to create a constructor. So as we have already mentioned in the earlier discussion, constructor is a special method which has same name as the name of the class. So I'll copy this and I'm going to paste it here, then open close bracket. Now here I am going to say cout. I'll say I am constructor, and I will say NL and a semicolon. Now let us try to run this program, but before I do that I will comment this line here which is calling the display method. So I'll comment it. So after commenting the method which is display ID, let us run this program and you will see the output as I am constructor here. Now let's try to understand what has happened. If you will see that in my program, when I created an object at line number 24 here, this in turn calls a constructor here. So basically execution of this line here, which is line number 24, it calls this particular constructor here, which I have highlighted for you. Now you will observe carefully that it displays an output I am constructor from this cout. Now one important point to note here is that I have not explicitly called the constructor, but constructor is called automatically when the object is created. So this is a default constructor, a constructor which does not take any argument, and it gets called when the object of that particular class is created. So therefore we see this output as I am constructor. So let me press enter and continue. Now what was happening when there was no constructor here or default constructor? Let me remove this and let me run the program once again. So I'll go to build, I'll say run, and this time you will not see any output. So basically what happens in CPP is that when there is no default constructor created in class, so in this case now I don't have any default constructor created, C++ will implicitly create one constructor for you which is a default constructor, but it does not do anything or it does not perform any operation. So when you run this program, internally C++ has created a default constructor similar to this, except that there is no statement inside that particular constructor. So this is called a concept wherein it is implicitly, or the default constructor is implicitly created for you by C++. So let me continue with our discussion on constructors. So basically then what is the purpose of a constructor? So a constructor can be used to initialize the value of a variable. In this case, what I'm going to do is I'll assign top of stack equal to maybe 0 if that is what you want to do. You can assign any other value as well, but stack should be initialized for a stack. TOS or top of stack should be initialized to 0 or -1 depending upon your implementation. Now since I have assigned value of top of stack as 0, I'm going to call the method again which is display ID. Let me uncomment this. So what happens when I execute this program, the flow is going to be something like this. So let me explain that with a drawing. So this particular execution will call the constructor here and it will display this value, and it will also initialize the value of top of stack as 0. And after that, when this particular line is executed, this will call display method or the display ID, and it will display the value of top of stack which is equal to 0 in this particular case. So let me go and run this program and see the output. So I will say build, I will say run, and I'll say build and execute. Now as you can see here clearly that I have output first as I am constructor and top of value is initialized to 0. And after that, when we do a call to the method display ID, it will display the value as you see here is 0. So let me press enter and continue. So that is how the constructors work in C++. Now let us understand what is a destructor. So as I had explained earlier, destructor is also kind of a special method. So I will copy this and I'll put it here, open bracket, close bracket, and it is preceded with a tilde sign. Now inside this, I will say, in the interest of saving time, I am going to copy this and put it here. and I will replace constructor with a destructor here. So I'll say the destructor. Now destructor, as you can see, has the same name as the name of the class, except that it is preceded by a tilde here. Now when is a destructor called? Destructor is called when the scope of this variable comes to an end. So this particular variable S1 which has been created has a scope which starts from this particular line, which is 27, or opening of this bracket, to the closing of this bracket. Now if I run this program, you will see that this particular destructor also gets called automatically. And when is that getting called? Just before the main method comes to end. And it is because the scope of S1 is getting terminated. So let's run this program and see the output. So I will go to build, run it, and say build and execute. Now you can see that IAM destructor is getting called here. That is because of this particular destructor that we have created, as I have already explained. So that is how the destructors work in C++.
Here's another question. What is the purpose of a destructor in C++? The options are displayed on the screen, and if you know the answer, please leave it in the comment section below. We have covered classes and objects as well as the OOPS concepts like encapsulation and inheritance, which is fundamental to constructing data in C++ program. We will now explore advanced topics in C++, including the standard template library and vectors in C++ STL.
What is a standard template library, or STL as you might call it? So what is an STL? STL is a set of general purpose classes and functions which are mainly used for storing and processing data. So basically in any programming language, there is a lot of data involved. You have to store the data, process the data. That is where STL comes into picture. So STL can be defined as library of container classes, algorithms, and iterators. So basically STL is a combination of containers which holds the data. Algorithms are basically the programming logic or the algorithm logic that work on their data, and iterators are basically used to access those data which are stored in the container. Then the idea to reuse already written and tested component which are defined in STLs. So basically there are already inbuilt STLs available. Of course you can create your own, but the ones that are already written for you or built and written for you, that can be reused. Why do we do that? It helps to save time and effort and enhance the quality of program. Since you are reusing the code, it will save you a lot of time and effort. And of course, the quality is improving because the STLs that are already written has been tried and tested by different developers and programmers over a period of time. So if you think or want to see it as diagrammatically, you can see that you have a standard template library represented by this image here, which contains classes and functions. Now, what are the various components of STL? So let us look at three major or key components of STL. One is container, another is algorithm, and another is iterator. So first of all, what is a container? Container are the objects that store data of similar type. So container is basically a location, you might call it, or a memory address, you might call it, where you store your data. So it constitutes a container. For example, you can have a list, you can have a vector that becomes a container in case of STL, for example. Then we have algorithm. What is an algorithm? Algorithm are procedures that are used to operate upon containers and manipulate them. So basically, as I had told earlier, that we have some algorithms written. Those algorithms can work on the data that is stored in the container. That is where algorithms come into picture. Then we have iterator. What is an iterator? Iterator behaves like pointers and are used to access the container element. So basically, if container is the place to store the data and algorithm is the logic that is applied on that data, then iterator is a reference or a pointer to that particular data with which you access those elements and basically perform operations on those elements. So let us continue with our components of STL discussion. Now the relationship between the three core components of STL can be represented diagrammatically, as you can see in front of here. So container stores all the data. This is your container. Then algorithms perform operation on the container with the help of iterator. As I've already mentioned that you access the elements with the help of iterators. And finally, iterators are responsible for connecting algorithms and containers and enabling manipulation of data stored in the container. So basically it is with the help of the iterator, you access the data that is stored in the container and perform or apply the algorithmic logic on those values stored in the container. So this is how the three core components of STLs are related with each other. So let us now continue our discussion on container in a little bit more details. So now what are containers? Now containers are objects that store related objects. So basically when I say related meaning suppose you have a collection of students. Now students are related in sense that it is a similar set of data which is students, or rather you can have a collection of maybe integers which are stored in a container, or different data types. So basically the emphasis here is we store related objects which has a relationship or some kind of a relation with each other. So containers are objects that store some other related objects. Now they organize data in the memory and are implemented using template classes. So they organize the data internally in the memory, and this implementation internally is facilitated with the help of template classes in CPP. Now STL can be grouped in three major categories. We have sequence container, we have associative container, and we have derived container. So under sequence we have vector, DQ, and list. Then under associative we have set, multiset, map, multimap, and under derived container we have stack, queue, and priority queue. So let us look at each one of them one by one. So what is a sequence container? Sequence containers are homogeneous elements in sequential order. So when you say homogeneous, it means similar kind of a data, and sequential order means it follows a specific order or a specific sequence. So under this category we have vector, we have DQ, and we have list. So let us discuss about each one of them one by one. So what is a vector? Now vector can be defined as a dynamic array. Dynamic because it can resize itself. Then here the elements are stored contiguously and can be accessed randomly. So the data which is stored in the vector are stored in a contiguous memory location, and you have an ability to access the elements randomly, meaning that you don't have to follow a sequence that go to first element and then go to second and go to third. If you want to go to third element, you can directly access that third element. That is known as randomly accessing the elements within a vector. Then what is DQ? It is double-ended queue, and it is a container where insertion and deletion is possible at both the ends. So in a queue, you insert data from one end and also insert the data at another end as well. Now it allows random access of elements and is dynamic in size. Similar to the vector, you can randomly access the data from the DQ, and also it is dynamic in nature. Then we have a list. What is a list? List is a container that allows bidirectional access of elements and fast insertion and deletion anywhere in the container. So as the point specifies or it makes it clear, then you can access in both the direction, front and back. I mean, you can move forward and move backward while accessing the elements of a list. Plus, when you do an insertion from a list or deletion from a list, it is very, very fast. And we shall see in some time why is the insertion and deletion very fast in the case of a list. So that is regarding the sequence container under which we have vector, DQ, and list. Now let us look at associative containers. So in associative containers, elements are stored in predefined order and not sequentially. Here elements are accessed directly using their keys. So earlier as we talked that the elements are stored in sequential order, wherein in the case of associative container, the order is predefined and it is not sequential in nature. So basically there are four types here. We have set. Set consists of unique elements. So basically if you think of a set as a set of numbers, it will store only unique numbers. There are no duplicates allowed in a set. So therefore it is called unique elements. the value of elements cannot be modified once it is added to a set. So once you have put in a value, you cannot just go about changing the value of that particular entry within a set. Then we have multiset. Multiset is a set, but it can store multiple elements having the same value. So going a step forward, in multiset is an enhanced set, you might call it, wherein you can have multiple elements having the same value. So basically duplicates are allowed in the case access that value with the help of a key. So it's a key value relationship. Then we have a multi-map. Look at what is a derived container. Derived containers are also known as container adapters. So we have basically three types under this. We have stack, we have a queue, and we have a priority queue. So what is a stack? We all know that it is a container that follows last in first out, also known as LIFO approach. New elements are added and removed at the same end. So when you put an element in a stack, if you want to remove it, that is the one which will get removed from the stack. So it's a last in first out approach or principle used in the case of a stack. Then we have queue. What is a queue? It's a container that follows first in first out mechanism. Now here elements are added at one end and removed at the front of the container. So in the case of queue, you add element in the one end and from other end it will get removed. That is a queue, and it follows the approach of first in first out principle or mechanism. Then we also have a priority queue. So in priority queue, it is a queue where each element has a fixed priority and the first element always has the highest priority. So whenever you put an element, it is assigned a priority, and in case it is a first element going in the priority queue, it becomes the element with the highest priority. So these are the various containers that are under derived container category. Now let us look at applications of containers about which we have already talked. We'll look at it with an example. Now there are various containers available in STL, but considering the scope of our discussion, we are only going to discuss or consider some of the most famous containers that are available in CPP. So let us get started with a vector. Now vector is one of the most widely used container. It supports dynamic array, hence memory is allocated at the runtime and the size can be changed accordingly. So this point I had discussed earlier as well, that vector is dynamically resizable and the elements are stored in contiguous memory location and can be accessed directly. So directly meaning that you can simply access it with the help of index, and it's very easy, and you can even randomly access the elements of a given vector. Now as you can see in this example here, in the main I have created a vector which is holding integer data type. Inside angle bracket I have defined int and I have given the name of the vector as v. Now this code will create a blank vector and no size is mentioned. In the other case, what I have done is I have created a vector in which I have specified integer type to be stored and I have given 4 integer elements 1, 2, 3, 4. So in this particular case, a vector will be created having size 4, as you can see here, which a size 4 meaning it can hold 4 integers. So this is how we basically create vectors in CPP. So as the data is added to the vector, it grows in size dynamically. So as I have already mentioned that it is dynamic in nature. So if you add an element in a vector, the size will grow dynamically. Dynamically meaning runtime while the program is in execution. So this is how a vector works. We shall look at all of this with the help of example in some time in our further discussions. Then next we have list. List is used to implement doubly linked list, which allows insertion and deletion of elements from anywhere in the list, which is not possible in the case of vectors, although they do not allow contiguous memory allocation. So list is similar to doubly linked list. Now doubly linked list, they have pointers. So when you insert an element in a list, actual insertion and deletion does not happen, but there is a pointer which is readjusted, and therefore the insertion and deletion is very fast. I mean, insertion or deleting an element does not actually insert or delete an element from the list, but pointer are repointed to the new elements and adjusted accordingly, and this operation happens very fast, and therefore the insertion and deletion in the list is very fast. Now a syntax for creating a new list can look like this. I can say std::list int, this int is the data type, and L. So this is creating a list for me. Similarly, if you want to create a list with an elements in this, you can see here that similar to vector and arrays, list can also be initialized with parameters. So here I am creating a list holding 3 integers 1, 2, and 3. So let us now look at map. Now map is a sequence of key value pair where each value is accessed by unique key associated with it. The value associated with keys can be modified, but the keys are not allowed to be modified. So let's say if I have a key value pair, a key could be an employee ID. Maybe if you are working in an organization, your employee ID could be a key, and a value could be another object which is storing information related to that particular employee. So it could be your name, it could be your designation, it could be your role, right? So in that map, you have an employee ID as your key and the related information stored as an object, which is a value, right? Now your employee ID is going to remain same always as long as you're in the company, but the value in those object which is stored against the key can change, meaning that with time your designation can change, your salary can change. So basically key remains same, but the values, corresponding value can get modified. So that is the primary feature of a map. So map can be created using following statement. You create a map map, then you specify the key or the key type and the value type, and you give the name of the map, for example. So a map is commonly called an associative array. This is a commonly used name in the case of a map. So against a key, you store a value in the map. So like this, you can have multiple keys and you can store a single value against a given key. And this key value pair is unique in nature. What are vectors? So we will go through these points to understand vectors in more details. So vectors are the same as dynamic array. Dynamic means which can resize itself. So they can resize themselves automatically when an element is inserted or deleted depending on the need for the task to be executed, where the storage of vector is handled automatically by the container. So as you can see that this particular statement clearly states that if you insert a value in the vector and if it does not have enough space to hold that element, the vector size will be resized, or let's say it will be increased. And therefore, as you have seen in the statement, that it is dynamic in nature, it will resize. So if you delete an element, it can shrink in size. If you need to add more elements, it will increase in size. So let us look at some important points of vectors. Vectors are the most important container in C++ standard template library. Now in vectors, elements are stored in sequential manner. So they can be accessed using iterators. So sequential manner meaning, let's say if this was a cell or rather an array, or let's say blocks, and these blocks are put next to each other. So this is, let's say 1, 2, 3, 4, 5. So they are sequential in nature, they are one after the another. So in vector, elements are stored in sequential manner. So if you put an element, let's say characters A, B, C, D, A, B, C, D, E. So these are stored in sequential manner in a vector. Now, unlike an array where only given number of values can be stored, vector can grow and shrink at runtime. So this I have already explained to you earlier that they are dynamic in nature. So depending upon whether you want to add more elements, it can either grow in size, or if you want to remove elements from vector, it can shrink in the size. Now element can be inserted at the end of vector container. So taking the original example which I had just explained to you. So in case if this was a vector for you and you have element A here, B here, C here, D here, you can add more elements at the end of this particular vector here. So elements can be inserted at the end of vector container. Also, vector has a lot of functions to perform operations, like you can sort the elements in a vector. You can do reverse sorting. For example, you can pop the element out of the vector. You can push elements within the vector. You can find the size of the vector. And there are a lot more functions that are available to you to perform various operations on the vector. Also, vectors are very efficient in terms of performance. So all these operations which you are trying to do in terms of sorting, reversing, popping, pushing, deleting, all these operations, they can impact the performance of the program. But the internal implementation of vector is such that you will have a very good performance in spite of performing all these operations with the help of methods that are provided in the vector. So vectors are very efficient in terms of performance as well. Now, what is the syntax to create a vector? As you can see here, you say vector, you define the type of object maybe, or a type of data here, and the name of variable. So if you want to say vector, you will say vector int, for example, open bracket, close bracket, and you can say here a variable name v1. So basically what is happening is you are creating a vector which can hold integer values, and the name of the vector is v1. So vector is basically a container to hold values. Now this has been explained with an example here, as you can see below, and also this is a representation of a vector, as you can see, which is holding decimal numbers 1, 2, 3, 4, 5, 6 here. So these are stored in sequential manner. This is one, then next, then next, then next, then next. So they are stored in sequential manner, and you have an option which we will see in some time in next few slides, that you can access the first element and the last element and the subsequent elements in between these first and last with the help of iterators. So moving on, let us look at what are some of the member functions of vector. Now this is a very exhaustive list, and I have taken number of functions or a subset of functions and shown here for your reference. I have taken it from this particular URL or website. Now iterators, if you define an iterator on a vector, it has good number of functions. As you can see, for capacity you have good number of functions, for modifier you have good number of functions. So we cannot cover all of them, but of course we will look at few of them. For example, begin is to return an iterator at the beginning. So if this was a vector here, let's say for example this is a vector and it is having, let's say, 4 elements A, B and C, A, B, C and D. Begin will point you to the beginning of the vector and returns iterator at the end of the vector. So like this you have other types as well, other member functions, like to find capacity. This is to check whether the container, which in this case is a vector, whether it is empty or not. Size is there, returns the number of elements. So like this you have few others as well in capacity. Then we have modifiers. Now what does clear do? Clear will clear the content, or it will remove all the contents within this vector, for example. So insert is basically to insert an element. So like this you have lot of member functions that are available in vector, and we shall look at some of them with an example also. So let us look at this example in the slide. We'll cover this example on our VMs also. But before that, let's briefly understand this piece of code in front of you. So here I'm making use of two functions, which is begin and end. Begin function returns an iterator that points to the first element in the vector. So if this was a vector, let's say I have this vector here again. So I'm putting few elements here, 10, 9, 8, 7, 6 and 5. So I'll put here 10, 9, 8, 7, 6 and 5. So what I'm doing is, this particular statement, it is a vector declaration. I'm saying that I want to create a vector which will hold integer data type, and the name of the vector is vector underscore example. Now what I'm doing is I'm running a for loop and putting in values in the vectors. So initially when the vector was created, it was empty. So one by one I'm pushing the elements at the end of the vector. So vector will have first 10, then it will have 10 followed by 9. So this way, after this loop is executed, this is how the vector will look like. Now after that, what we are trying to do is I'm creating a begin and an end, or rather I'm making use of begin and end function. Basically this is a syntax to create an iterator which points to the beginning here. So let me go and clear some of this here. So if this was your vector, this auto I equal to vector example begin will point the vector in the beginning, and the end will point here. Now we can access the value of that particular element within the vector using star of I. You can see, so once we iterate through the vector using this iterator, it will display all the values from 10, 9, 8, 7, 6, 5, as you will see shortly with an example we will try. So basically, this is an example of how we make use of vector iterator. So now let's move on and see some of the vector modifier. So what is a modifier? In this case, we say pushback. Basically, pushback functions insert an element from the end. So if we had a vector, for example, so if you assume this to be the beginning, this to be the end, insertion happens at the end. So what we are doing it here is we are declaring a vector and start to add element to that. After we do that, we create an for loop and display the elements one by one. Now after that, we made use of this method here. So if you will look carefully, we are trying to pop the element out of the vector. So if this was my vector, let's say, which had 10, 9, 8, 7, 6, 5 here, if I pop the elements, it will remove only this last element. And if you after that display the entries from the vector, you will see the output is going to be 10, 9, 8, 7, 6 and not 5 because it has already been popped from the container or the vector. So this is how we basically make use of some of the modifiers. Modifiers are the functions which modify the content of this container, which is a vector container in this particular case. So moving on, we will look at some capacity functions. So what are capacity functions? As you can see in the slide, we have size, we have capacity, we have resize function. So size returns the number of elements present in our current vector. Then capacity returns the size recently allocated to vector. And then you also have an option to resize it. So let's say we are declaring a vector here. After that, what we do is we are putting 10, 9, 8, 7, 6, 5 entries in the vector. So it is 6 elements we are putting. Now, if you try to go ahead and display the size, this will return you the number of elements in the vector, as you can see. Now, capacity returns the capacity of the vector. And then finally, you can resize it also. If you will resize it, the size shrinks to 4. So this is how you can make use of various capacity functions that are available in vector container. So let us head to our lab VMs and try all this with some examples.
Now let's take up a question. Which of the following method is used to add an element at the end of a vector in C++ STL? Options are given on the screen, and if you know the answer, please leave it in the comment section below. We have covered the basics of STL and vectors in C++ programming. Next, we will discuss the file handling techniques, streams, and other advanced C++ functionalities.
Files and streams. Files are used to store data in a storage device permanently. In C++, we have a set of file handling methods. These include ifstream, offstream, and fstream. What is offstream? This stream class signifies the output file stream and is applied to create files for writing information into files. Then we have ifstream. This stream class signifies the input file stream and is applied for reading information from files. Finally, we have fstream. This stream class can be used for both read and write from and to files. Now, let us execute basic examples for understanding file handling methods in C++. Now, let us try to create a file. So this particular code segment is used to create a file. Let us name our file as Edureka. Now let's run the code. As you can see, a new file has been successfully created and our file is right here. Now let us try to execute another program which follows the write function into the file. Now this particular code is used to write data into the file that we have created. So the data that we will be writing into our file is Edureka Happy Learning. Now let us try to execute this code. As you can see, the message has been successfully written into the file and the message has been displayed here. Now let us try to execute another program which reads the data present in our file. So this particular code is used to read the data which is present in our file. As you can see, the compiler is reading the message that we have written into our new file, that is edureka.txt. Now we shall execute the last program based on file handling techniques, which is used to close the file that we have opened. So this particular code segment is used to close the file that we have opened, which is edureka.txt. Let us run this code to close the file. As you can see, the code has been successfully executed and the file has been closed.
In a previous module, we discussed on file handling techniques, streams, and other advanced C++ functionalities. Moving forward, we will explore advanced topics such as exception handling, dynamic memory management, and multithreading in C++.
Now with this, let us move on to the next segment, which deals with exception handling. So what is exception handling? Exception handling is a phase which deals with the handling of errors and exceptions that rise in runtime due to the mistakes in code or invalid inputs entered by the user. In C++ programming language, we have two types of exception handling, that are runtime exception handling and compile time exception handling. Let us go through some examples to understand exception handling in a better way. So this particular example is based on exception handling, and we are going to try the try and catch block here. You can see that the code has been successfully compiled, and the code was designed to divide 25 by 0, and the exception should be attempted to divide by 0, which is displayed here in the terminal. Now let us try to execute another example based on exception handling, where the catch block will be facing a failure. Let us see how does it happen. You can see that the code has been successfully executed. This kind of approach is used when catch block and try block both face failures. So in this situation, we have to specify a default catch block which will execute a default exception. As you can see, we have default exception message printed here in the terminal. Now let us try to execute one last example based on exception handling, which is having multiple catch blocks in a program. So here we have multiple catch blocks included in our program. Now let us try to execute this. You can see that the code has been successfully executed and the output has been printed here. Now with this, let us move on to the next segment, where we will learn dynamic memory management in C++. Firstly, we shall deal with dynamic memory allocation. Dynamic memory allocation can be defined as a procedure in which the size of a data structure is changed during the runtime. In C++, the new operator is used to allocate memory at runtime, and the memory is allocated in bytes. So the syntax for dynamic memory allocation using the new keyword in C++ is data type pointer is equals to new keyword and the data type. Now let us execute an example based on dynamic memory allocation. As you can see, the code has been successfully executed, and you can see the memory allocated for the data in our program, which is 1, 2, 3, 4, and 5. Now with this, let us move on to the next concept, that is deallocation. Deallocation acts as the free method in C programming. Once heap memory is allocated to a variable or class object using new keyword, we can deallocate that memory space using delete keyword when the memory is no longer needed. This improves the program efficiency. Let us move on to the next concept, that is signal handling. Signals are the interrupts delivered to a method by software package which may terminate a program untimely. You'll be able to generate interrupts by pressing Ctrl+C on an operating system, Linux or Windows OS. Now we shall execute a simple example based on signal handling, where we'll try to print a message called Welcome to Edureka. Now let us run this program. As you can see, the program has been successfully executed, and the terminal is starting to produce the signal Welcome to Edureka for infinite number of times. Now we have to stop this in order to cancel the signal generation. We have to just press the stop button in order to stop the signal generation. The signal generation has been successfully stopped. Let us move on to the next concept, which is multithreading. Multithreading is a special sort of multitasking, and a multitasking is that feature that enables your PC to run 2 or additional programs at the same time. In general, there are 2 kinds of multitasking. First one, process-based, and the second one is thread-based. Process-based multitasking handles the execution of programs. Thread-based multitasking deals with the execution of items of identical programs. A multi-threaded program contains 2 or additional elements which will run at the same time. Every part of such a program is termed as a thread, and every thread defines a separate path of execution. C++ does not contain any constitutional support for multi-threaded applications. Instead, it depends entirely upon the OS to produce this feature. The C++ programming language has the following stages in multi-threading. First, to create the thread. Next, pass arguments to the thread. Then, join or detach threads. And finally, to terminate the thread. Now, let's execute all these 4 stages to understand the terminology of multi-threading. And before that, let us understand the syntax of multi-threading. So in the syntax of multi-threading, we are supposed to include the library which is pthread.h in the program in which we are processing multi-threading. Let us execute the program for creating a thread. So this particular program should successfully create a thread. You can see that there are threads created and the message is being printed along with the threads. Now, followed by this, we shall try to pass some arguments to different threads. So this particular program should be able to pass multiple messages to multiple threads. Let us execute that. You can see that the output is being generated here, and we have created 5 different threads and we have allocated a single message to every single thread. Now with this, let us move on to the next stage where we will try to join and detach threads. So this particular program should join and detach threads. Let us execute this. You can see that we have created 5 different threads and we have attached 1, 2, 3 and 4 threads, and the 0 thread is being detached. Now with this, let us continue with our final process, which is none other than terminating a thread. So the syntax for terminating a thread is include pthread.h library, and you need to write pthread exit status, and that's how you terminate a thread. Let us continue with our next topic, that is containers. Associative containers that store elements in a mapped fashion are called as maps. All the elements in a map are stored in a key-value pair, but each key is unique. Sorting is done with the help of keys and the values are associated with each key. Values can be inserted and deleted whenever required. So the syntax for a container is map key type, value type, and map name, followed by a semicolon. Now we shall execute an example based on containers. So this example is based on containers. Now let us try to execute it. As you can see, the program has been successfully executed and we have the container where we have the roll numbers along with their marks. Let us try to execute another example based on containers. So this is another example based on containers. Now let us try to execute this program and see the output. You can see that the program has been successfully compiled and the output has been successfully generated here. The output is the key value pair which has been displayed here. Now with this, let us wind up our session with some most important interview questions that are asked based on C++. So we shall deal with 4 important programs. They are Fibonacci numbers in C++, then followed by that we have quicksort in C++. Then we shall understand call by reference in C++, and finally, what is type conversion in C++. These interview questions are answered in detail in the article written based on C++ tutorial. The first one is the Fibonacci series in C++. Now let us try to execute the first program, that is generating Fibonacci series using C++. So now let us enter the numbers. You can see that I have entered the number as 5 and the Fibonacci series for the same has been successfully generated here. Now let us try to execute the second program, which is none other than the quicksort in C++. Don't worry about the code, we will mail you the code whenever you ask it for. So this particular code is designed for running quicksort algorithm using C++. Now let us try to execute this. As you can see, the code has been successfully executed and now it is asking for the number of elements to be sorted. Let me give a random number, that is 10. Now let me provide the elements to be sorted one by one. Firstly, I'll provide 5, then I'll provide 1, next 4. Followed by that, let me enter 6, then 7, then 8, later 2, then 3, then 9, and finally 10. Let us see if the numbers get arranged in a proper way or not. You can see the numbers have been successfully arranged in the proper manner. which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now with this, let us move on to our next question, that is call by reference. Let us execute a simple example based on call by reference. So this particular example is based on call by reference. This example has been already executed while we were discussing call by reference in reference variables, though we shall try to execute this one more time. You can see this program has been successfully compiled now, and we got the output, and the output has been displayed on the terminal. Finally, we reached to the last question, which is type conversion in C++. So what is type conversion in C++? Type conversion refers to the conversion from one type to another. The main idea behind the type conversion is to make variable of one type compatible with the variable of another type to perform an operation. Now let us try to execute a simple example to understand type conversion. So this particular example is based on type conversion. Now let us try to execute this program and see how does it work. As you can see, the code has been successfully executed and the output has been generated. As we specified in the code, we have three different variables of three different data types. Firstly, we have int1, which is an integer data type, which is saving 100 as its value. Followed by that, we have a character1 variable, which is of character type, which saves C inside it as its value. And third variable is FLT1, which is a float data type variable, which will be storing the sum of integer 1 plus 2.7. As we specified the operations, firstly, integer 1 will be saving the value of integer 1 plus character 1. We have integer 1, that is 100, and character 1, C. So the value of character C in ASCII is 99. So the summation of 100 and 99 gives us 199. And now finally, we have FLT1, which will be storing the value of int1 plus 2.7, that is 199 plus 2.7. Now what happens is that the data type int will be converted into float, and the final value, which is none other than 201.7, will be stored in FLT1 variable. So this is how type conversion takes place.
Now let's take up a question. Which C++ feature is used to achieve concurrent execution of multiple tasks? And the options are option A, multithreading, option B, file handling, option C, exception handling, or option D, dynamic memory management. If you know the answer, please leave it in the comment section below. Having explored advanced C++ concepts like exception handling, dynamic memory management, and multithreading, in our next module, we will compare C, C++, and Java, as well as Python and C++ to understand their strengths and use cases.
The first comparison in our list is programming paradigm. In C++, the programming paradigm followed is object-oriented programming, while in Java, the programmers follow pure object-oriented programming procedure, and C language is completely a procedural language. The next comparison is the origin. The C++ programming language is based upon C language, while Java is based on both C language as well as C++. And finally, the C language is based on assembly level language. And the next comparison is developer. The developer of C++ language is Brane Strausstrup in the year 1979. When it comes to Java, Java is developed by James Gosling in the year 1991. And finally, C language is designed by Dennis Ritchie in the year 1972. The next comparison is the translator. C++ follows compiler to translate the code into binary level code. And similarly, when it comes to Java, Java uses interpreter to translate the code into binary level language. And finally, the C language uses a compiler as a translator. The next comparison is platform dependency. The C++ programming language is platform dependent. Similarly, when it comes to Java programming language, Java is platform independent, while on the other hand, C is similar to C++ and it is platform dependent. The next comparison is code execution. C++ follows direct code execution, while in Java, we follow JVM, which is Java Virtual Machine, where the code will be sent to Java Virtual Machine for translation and code execution. And C follows direct code execution method. The next comparison is approach. C++ follows bottom-up approach, and Java also follows the same bottom-up approach, while on the other hand, C follows top-down approach. The next comparison in the list is file generation. The C++ generates .exe files while Java generates .class files, and C, similar to C++, generates .exe files. The next comparison is preprocessor directives. The C++ follows #header and #define to include the preprocessor directives, while Java uses import option to import the packages it needs to compile the program it is running. And on the other hand, C, being the predecessor of C++, follows the same method of using #header and #define to include the preprocessor directives. The next comparison is the keywords. C++ has 63 keywords while Java has 50 defined keywords, and C has the support for 32 keywords. The next comparison is data types. So the data types like union and structure are supported in C++ and C, but not in Java. The next comparison is inheritance. C++ and Java both support inheritance, but in case of Java, it does not support multiple inheritance. To support multiple inheritance, Java has to use a special feature called as interface. And on the other hand, C does not support inheritance. The next comparison is overloading. The C++ programming language supports overloading through polymorphism. And similarly, the overloading process is also supported in Java programming language, but the only difference is operator overloading is not supported in Java programming language. On the other hand, C language does not support overloading. The next comparison is based on pointers. Pointers are supported both in C language as well as C++, but it is not supported in Java programming language. The next comparison is memory allocation. The C++ programming language uses new keyword to allocate memory to a program, and similarly, to delete the memory allocated, it uses delete keyword. When it comes to Java, Java uses a special software called as garbage collector to remove the unwanted memory spaces. And when it comes to C language, we use calloc function, malloc function, and realloc function to allocate the memory to a particular program, and we use free function in order to delete or free the memory space from a particular program. The next comparison is exception handling. The exception handling is supported in both Java and C++ language, while it is not supported in C language. The next comparison is templates. The C++ programming language supports templates, but Java and C language does not support templates. The next comparison is destructors. The use of destructor is supported in C++ language, and it is not supported in case of Java programming language. And when you come to C language, there are no constructors, neither destructors. The next comparison is multithreading or interfaces. Both C language and C++ language will not support multithreading or interfaces, while Java has a special feature which supports interfaces in order to overcome the problems of multiple inheritance. Now, the next comparison is database connectivity. Both C language and C++ language are not capable to support database connectivity, while Java can support database connectivity. And the final comparison will be storage classes. The C++ language will support storage classes, while Java will not support storage classes. C, being the predecessor of C++ programming language, it has a support to the storage classes.
C++ and Python both are object-oriented programming languages, as I've already mentioned earlier. However, they are very different when compared to each other. So first of all, let's talk about the simplicity. By simplicity, we refer to the ease with which you can write the code. Python is much simpler when compared to C++. This is because C++ requires you to write too many lines of code. But with Python, the same can be achieved within a few lines. Syntax. Syntax basically defines the set of rules in programming language that are used to define the symbols present in the program. Every programming language has its own syntax. In case of Python, the syntax is much simpler as it is designed to resemble the English language. Python makes use of whitespace characters to distinguish between different blocks of code. In C++, you will have to make use of curly braces to mark different blocks of code. Not just that, there are many other syntax constraints like declaring variables, using semicolons, etc. Compilation. Compilation is the process where the compiler converts the high-level programming language into machine-level language for the computer to understand it. Python is an interpreted language, and it runs through an interpreter during compilation. C++, on the other hand, is a pre-compiled programming language and does not need any interpreter during compilation. Performance. As mentioned earlier, Python is an interpreted language that focuses on reducing complexity and optimizing programmer efficiency. However, this comes with the cost of compilation speed. C++ has the advantage of being statically typed or compiled language. The performance crown goes to C++ for creating more compact and faster runtime code. Therefore, in applications that have high performance dependencies, C++ would be a better choice than Python. Scope of variables. Scope of variables refers to the region of the code where the variable can be accessed. In Python and C++, you can specify both local and global variables. However, in Python, the variables that are declared within loops can be accessed outside the loops as well, but the same is not possible in C++. Functions. Python functions do not have restrictions on the type of argument and the type of its return value. In C++, the function can accept and return the type of value which is already defined. Garbage collection. Garbage collection refers to recovering memory by clearing variables and data that is no longer in use. For efficient memory management, Python provides built-in garbage collection system. C++, on the other hand, does not require garbage collection as it has no garbage. Rapid prototyping. Rapid prototyping is possible with Python as code is small, whereas with C++ it is not possible as the code size is large. Type checking. Python is dynamically typed language where the type checking takes place during runtime. C++ is a statically typed language. Therefore, all the variables that are used need to be explicitly declared and determined at compile time. Application areas. Python is mainly used in web applications, desktop GUI applications, software development, scientific and numeric fields, business applications, etc. C++ finds its use in areas such as gaming, database softwares, etc. Usage in AI. AI, or artificial intelligence, is one of the most in-demand technology trends in today's world. AI is going to change the world more than anything in the history of mankind, more than electricity. When it comes to AI, you can make use of Python as well as C++. But most developers prefer Python as it provides a huge set of dedicated AI and ML libraries. Popularity. Python has huge community support. When it comes to popularity, beginner and novice programmers turn towards Python. C++ has dedicated followers online, but only people who have some experience in the field show a lot of interest in C++. Also, Stack Overflow 2020 Developer Survey places Python at the 4th place when it comes to popularity, and C++ is at the 10th position. Most loved language. According to Stack Overflow's Developer Survey 2020, Python is ranked 3rd when it comes to the most beloved programming languages. However, C++ is not present in the top 10 list. Most wanted language. In the same survey, Stack Overflow grants the 1st place to Python with 30% demand. C++, on the other hand, is at the 7th place with 8.6%. Salaries. When it comes to average salaries drawn by Python and C++ developers, Python developers seem to have an advantage with about $59,000, whereas for C++ developers, it is around $53,000 globally.
We have covered comparative analysis between programming languages and their applications. Finally, we will conclude with C++ interview questions and answers to prepare you for technical assessments and interviews.
Let's begin with the questions. The first question is, what is C++? C++ is an object-oriented programming language that is invented by Jarne Stroustrup in 1985. C++ is a superset of C with a major addition of classes in C language. And the main point is, C++ is a versatile programming language combining procedural and then object-oriented and also generic features used in various domains like software, game development, embedded system, and high-level applications as well. And the next question is, What is the difference between C and C++? C language was developed by Dennis Ritchie, whereas C++ language was developed by J. Stroustrup. C is a procedure-oriented programming language, whereas C++ is an object-oriented programming language. C is a subset of C++, whereas C++ is a subset of C. And the next point is, C language follows top-down approach, whereas C++ language follows bottom-up approach. Then, C language has 32 keywords, whereas C++ language contains 52 keywords. Following this, next question is, what are the advantages of C++? The first advantage we can say is object-oriented programming. C++ is an object-oriented programming language focusing on objects and making code manipulation easier than a procedural language. Next, memory management. This language provides developers with a total control over memory management and achieved through the dynamic memory allocations using pointers like malloc and calloc. And the next advantage is compilation speed. C++ is preferred choice for speed due to its faster compilation and execution time. And the next one is library support. C++ language supports standard template library that offers numerous functions for efficient code writing, including support for containers like hash tables, maps, and sets. And then we have multi-paradigm programming. C++ program utilizes multi-paradigm programming, which involves planning, logic, structure, and procedure. The next question is, what are the different data types present in C++? Basically, we have three main kinds of data types. They are primitive data type, derived, and user-defined data type. In primitive, we have integer, character, boolean, floating point, double floating point, and then void. Whereas in derived data type, we have function, array, pointer, and then references. And then user-defined data types are class, structure, union, enum, and type-defined. And the next question is, what are classes and objects in C++? Classes is a user-defined data types which includes data members and member functions. Member functions are the functions that are used to carry out operations on data variables, which are known as data members. And then, objects is an instance of class. An object can also be referred to as a variable of a class because a class is a user-defined data type. And the next question is, what is hash include IOStream and using namespace standard? Hash include IOStream is a preprocessor directive used in C++ language to include input or output functions. And then, using namespace standard is a declaration that allows you to use names from standard namespace without explicitly specifying them, resulting in more compact code. Next question is, what is difference between structure and class? Members of a structures are public by default, whereas members of a class are private by default. Structure can have a constructors, but they can't be invoked automatically, whereas class can have a constructor and they can be invoked automatically. Structure has a limited option or a no support for inheritance, whereas for class supports inheritance for a code reuse and hierarchy. In structure, memory allocation is often on the stack, whereas in class, memory allocation is often on the heap. And the next question is, what do you mean by call by value and call by reference? Call by value passes the copies of actual parameters to the function's formal parameters, which consumes more memory as it involves duplicating data. When it comes to call by reference, this will passes the address of actual parameters to the function's formal parameters, where it is a memory efficient as it avoids the duplicating of data. Following this question, we have, what is the difference between reference and pointer? A reference value can't be changed, whereas pointer value can be changed. References requires an existing value to become an alias of, so it can never contain a null value, whereas pointer is also known as null pointer and it can hold or point at a null value. references can't work with the arrays, whereas pointers can work with arrays. In references, to access the members of a class or a structure, it uses a dot operator, whereas in a pointer, to access the members of a class or structure, it uses an arrow operator. And the last difference is, in reference, it is simple to access or use memory location of a reference directly, whereas in pointer, memory location can't be readily accessed. Instead, a dereference must be used. Next question is, define token in C++. A token is the smallest unit of program that the compiler recognizes in C++. We can define token as, tokens are the building blocks of program and can be categorized into several types. Here are some common types of tokens in C++. First one is keyword, identifier, literals, operators, special symbols, and then constants. And the next question is, what are access modifiers? Access modifiers are keywords that are used to control the access level of class members. They define how members of a class can be accessed from outside the class. C++ supports three types of access modifiers. They are public, private, and protected. Following this, we have question as, can you compile a program without a main function? Yes, it is possible to compile a program without including main function by using macros. For example, this is the code we can run. Here you can see #define function main. This is nothing but a using macros. If you run this code snippet, we will get the output as Edureka. And the next question is, difference between equal to and assignment operator. The equal to operator is a comparison operator used to test whether the two values are equal or not. If the values on the left and right sides are equal, it returns true value, otherwise it will return false value. And the next, assignment operator. This operator is used to assign a value on a right and stores it in a variable on a left. And the next question is, what are the various OOPS concepts in C++? We mainly have 6 types, and they are class, object, inheritance, polymorphism, abstraction, and then encapsulation. And the next question is, explain this pointer. This pointer is a keyword that represents a pointer to a current instance of a class. This pointer is used to distinguish between local and class members when they share a same name. This helps in maintaining a reference to an object on which a member function is invoked. Now we will get into the intermediate level of questions. And the first question is, what is polymorphism in C++ and mention its types? Polymorphism, in simple words we can say, having several forms. Its behavior varies depending on the scenario. This happens when we have multiple classes that are related to each other by inheritance. There are 2 types of polymorphism. First one is a compile time polymorphism and second one runtime polymorphism. And the next question is, what is the difference between an array and a linked list? The first difference is, arrays have a fixed size, whereas linked lists have a dynamic in size. And the next one is, arrays are stored in contiguous memory locations, whereas linked lists are non-contiguous memory locations. In arrays, insertion and deletions may involve shifting of elements, whereas in linked list, there is no need for shifting of elements for insertion and deletion. And the next point is, arrays are primitive data structures, whereas linked lists are dynamic data structures. And the last point is, in arrays, memory is allocated at a compile time, whereas in linked list, memory is allocated at a runtime. And the next question is, what is the difference between function overloading and operator overloading? Function overloading is also known as method overloading, which allows us to define multiple methods with the same name, but with a different parameter list in the same scope. Then, operator overloading enables the operator to extend their predefined operational meaning based on their operands, data types, or classes. Following this, we have another question, that is, what is the difference between while loop and do while loop? First, we'll see for do while loop. So this will check the condition after the execution of a loop body. This body loop is guaranteed to execute at least once, regardless of any initial conditions. And one more point, if the condition in a do-while loop is false, the body will execute at least once. I hope you understand this one. Let's see for the syntax. So first, you can see that do with the braces of statements and then you have a condition. So when we execute the code, it will execute all the statements within that scope. After that, it will check for the conditions. So that absolutely it will at least execute for once. Now we will see for while loop. While loop checks the condition before the execution of a loop body. If the condition is initially false, then loop may not execute at all. In other words, we can say as if the condition in a while loop is false, then no statements will execute within the loop. Let's check for the syntax. We can see that while in braces condition and below that statements we have. So in the beginning of the code only, it will check for the condition. If that's satisfied, then only it will execute for the statements. And the next question is define namespaces in C++. The namespace keyword is used to declare the namespace, followed by the name of a namespace. And then within the namespace block, entities like variables, functions or classes and so on are specified. Elements inside the namespaces are accessed using a scope resolution operator. And the last point is namespaces helps in preventing naming conflicts by encapsulating entities within a specific scope. And the next question is explain constructor in C++ with example. A constructor is a specific member function of a class that is called automatically when an object of a class is created. Constructor have the same name as a class name and no return type including void. Next is the example. You can see the example here. Here we have used class name as a simple class and also a constructor name as a simple class. So when we execute this one, it will call a constructor by itself when an object is created. And the next question is, what are destructors in C++? A destructor is a specific member function that has the same name as a class but begins with a tilde. It is invoked automatically when an item is removed from scope or manually erased. And then the destructor is used for housekeeping operations including releasing reserved sources. Following this, we have another question is discuss the differences between prefix and postfix. In prefix, the operator is placed before the operand, whereas in postfix, the operator is placed after the operand. In prefix, the operand is modified before its value is used or returned, whereas in postfix, the current value of an operand is used or returned before it is modified. And the next point is, in prefix, we write operator as ++x, whereas in postfix, we can write operator as x++. And the final point is, in prefix, it returns the modified value of an operand, whereas in postfix, it returns the original value of an operand before modification. And the next question is, compare compile time polymorphism and runtime polymorphism. Compile time polymorphism occurs during compilation phase, whereas runtime polymorphism occurs during program execution. In compile time polymorphism, the binding of a functions is determined at a compile time only, whereas in runtime polymorphism, the binding of functions is determined at a runtime. And the last point, compile time polymorphism is more efficient than runtime polymorphism as there is no runtime overhead, whereas runtime polymorphism is less efficient than compile time polymorphism. And the next question is, what is the difference between new and malloc? New is an operator, whereas malloc is a library function. And the second difference, new allocates a memory and calls a constructor for object initialization, whereas malloc allocates a memory and does not call a constructor. And the next difference is, return type of new is exact data type, whereas in malloc it returns void. And the final difference is, new is faster than malloc because an operator is always faster than a function. And the next question is, define friend function. A friend function is a function that is not a member of a class but has access to its private and protected members. This enables a friend functions to act on class's private or protected members as if it were a member function. And then, friend functions are often used when a function needs access to class internals but doesn't logically belongs to the class itself. Next question is, what do you know about friend class and friend function? A friend class is a class that can access both the protected and private variables of a classes, where it is declared as a friend. And then, friend function. A friend function is a function that accesses private and protected members of a class, operating as if it were a member function. They are commonly used when a function needs access to the class internals, but doesn't belong to the class itself. Next question is, what is function overriding? We'll explain this with the example. If you inherit a class into a derived class and provide a definition for one of the base class's function, again inside a derived class, then this function is called as overridden function, and this mechanism is known as function overriding. And the next question is, define inline function. Can we have a recursion inline function in C++? An inline function is a request to compiler that inlines a function to a main function body. It can become an overhead if the execution time is less than the switching time from caller function to called function. For example, to make a function inline, use keyword inline before and then define it before it calls. An inline function can't be recursive as it does not maintain a piece of information on the stack necessary for recursion. Now, we will explore the advanced level of questions. The first question is, what is a virtual function? A virtual function is a member function in the base class that was redefined in a derived class. Here, virtual function uses a virtual as a keyword to declare it. And then, it guarantees that the right function for an objective is called, despite the kind of reference or a pointer used for function call. Virtual functions are mostly utilized for polymorphism at a runtime as well. The next question is, what is the difference between virtual functions and pure virtual functions? The first difference is, virtual functions can have a default implementation of a code, whereas pure virtual functions can't have a default implementation of a code. Virtual functions used for running runtime polymorphism, whereas pure virtual functions used in the advanced concept of runtime polymorphism where interfaces are required. In virtual function, definition of a function is provided in the parent class itself. In pure virtual function, definition of a function is not provided in a parental class. In virtual function, there is no abstract class concepts, whereas in pure virtual function, the class is called an abstract class if there is at least one pure virtual function. The next question is, what is a virtual destructor? We'll understand with a scenario. When destroying a derived class object or an instance using base class pointer object, a virtual destructor is invoked to free up a memory space. So this ensures that derived class destructor is called first, followed by the base class destructor. This prevents the memory leak. And the next question is, what is a scope resolution operator? The scope resolution operator is used to differentiate between local and global entities when defining the scope of variables or a function. The main purpose of using scope resolution is, first one, to provide access to members with a certain namespaces, class or global context. And another purpose of using scope resolution is, it is also used to define functions outside the class definitions. Following this, we have another question, that is, how delete function is different from delete. Deallocating storage, which is allotted by dynamic memory allocation, is done by using both delete and delete function. Here, delete function is used to deallocate a storage of an array, whereas delete is used to deallocate the storage of a single object. To prevent memory leaks, make sure to use deallocate memory using delete keyword after allocating it with a new keyword, whereas if you use new function keyword to allocate an array of an memory, and to delete that one, you have to use delete function keyword to deallocate memory. And the next question is, what is an abstraction in C++ and when to use? Abstraction is a fundamental concept in object-oriented programming language. It is a method of keeping unnecessary data hidden and giving a user only the information that they needed. This facilitates understanding the usage of code. Following this, we have question as, is constructor overloading possible? If yes, then explain, and if no, then why? Yes, it is not possible to overload a destructor. The destructor is just one method for destroying a constructor created by object. As a result, destructor can't be overloaded. Destructor neither requires any argument nor returns any value. And the next question is, what do you understand about static members and static member functions? Static members are a class components that are shared by all instances. They exist independently of object instantiation when declared with the static keyword, and also allowing for class-wide properties or constants. Static members, which can be accessed by the class name, and also are useful in the situation when common data is required across all objects in the class. When it comes to static functions, a static member function can be called even if no class objects exist. It is accessed using only the class name and also with the scope resolution operator. And the next question is, what is an overflow error? Overflow errors occurs when a computational result in a value exceeds the data type's representational limits and also causing a loss of precision. This is a common in numeric data types like integers and also leading to unexpected behavior or data corruptions. To prevent these overflow errors, data types must accommodate a range of values which is generated during computations. For example, let's assume that data variable size is -10 to +10. So on that point of time, if you declare a variable size as 22 or 33, that leads to an overflow error. Here you can see the actual data type, integer data type value range. And the last question is, what does the scope resolution operator do? The scope resolution operator is used to access members of class or namespaces that are declared outside their normal scope. For example, it can be used to access static members, global variables, or functions specified outside the class or a namespace. With this, we have come to end of this session. I hope you enjoyed this video. If you did, make sure to like and subscribe to our YouTube channel. Thanks for watching and keep learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!